Hi, this is John Sanmez from Pluralsight, and welcome to the course on Java Fundamentals. This is part one of the Java Fundamentals course, and in this course we are going to be learning about that programming language called Java. So let's go over what we're going to cover in this course. Well, this course is basically meant to be an introduction to Java. And by introduction, what I mean is that it is both applicable to a beginning programmer, so someone who's really never programmed before. I'm going to teach you from the beginning some of these core programming concepts, but teach you them in Java, or just someone who's new to Java. And some of the concepts are going to be similar to what you've seen in other programming languages, but I'm going to show you how to do the things that you may already know how to do in Java. So really, either one of these categories is going to be able to benefit from this course. We're not going to go too much into the details or advanced Java, so even someone who is somewhat experienced with Java would probably be able to benefit in filling in some gaps and some understanding of the Java language, because Java is fairly big. Also, this is a two-part course, so this is the first part, and in this part we're going to really cover more of the basics, and then in the second part we're going to get into some of the more of the advanced stuff here. And really what we're going to cover in this course is the language. We're going to cover a little bit of some of the class libraries that are out there for doing mainly things like file I/O, and a couple of the other areas where it's important to know just to be able to function in Java. But the basic goal of this course is to make it so that you would be able to program in Java and be productive using the Java language. Now, to really be a Java developer, or to really succeed as a Java developer, you'll have to learn a little bit more of the platform and some of the technologies. But by the end of this course, you should definitely be able to write some Java code and understand really the depth of the entire language. We're going to cover within the two parts really the whole Java language. And, Java is huge. We're not going to cover every single bit and every part of Java. And because Java is more than just a language, it's all these libraries, it's a lot of technologies, and this entire platform, we won't be able to cover that entire thing. But like I said, at the end of this course, you should be able to program in Java and really have a good grasp of the language. So here are some of the topics that we're going to cover in this course. The first thing that we're going to do is talk about Java in general. Just a brief introduction to what Java is, just some hello world programming to get us started and to really break the ice with Java. Then we're also going to talk about variables and operators, how to use the variables, declare variables, types, and what kind of operators are available in the Java programming language. We're going to go into classes. I'm going to show you how to construct some classes and objects and how to use them and how that is done inside Java. Then we're going to go into control statements. These are going to be if statements, loops, all these constructs that allow you to have conditional logic inside of your code. Then we're going to go into a little bit more of a complex topic of inheritance and composition. I'm going to show you how to do inheritance in Java and how it works, and then how to also do composition. And it's okay if you don't understand what these terms are now. We're going to cover these in these modules. And then finally, we're going to go into generics, which is basically a way in Java for you to be able to reuse a lot of your code to make it applicable to different types. And so this is really what we're going to cover in the first part. Like I said, the second part of the course, the second course, will actually cover some more advanced topics, and we'll get into things like doing file I/O and threading and things that are a little bit more advanced. So in this module, we are going to be introducing Java. We're going to talk a lot about what Java is and how it works, and we're going to go through some things to get you just familiarized with Java in general and some of the tooling that we'll use in order to develop a Java application. So let's go over what we are going to cover in this module. The first thing that we're going to do is talk a little bit about Java. What is Java? How does it work? A little bit of the background and history of Java. Then we're going to introduce a really important concept in Java, which is the JVM, the Java Virtual Machine. I'm going to talk a little bit about virtual machines in general and how they work so you can understand what's going on here, and then specifically how the JVM works, or what the JVM does and what benefit it gives you as a Java programmer. Then we're going to go ahead and we are going to write up a Hello World program. We're going to write this program, we're going to compile it, we're going to talk a little bit about the parts of it and how it works so you can understand what the basic, simplest program that you can write in Java is. Then we're actually going to start to look at some IDEs. And the main IDE that we're going to use in this course is Eclipse. So I'm going to show you where you can get Eclipse and download it and install it, and some basic features of Eclipse. We're not going to go very in-depth into all the features of Eclipse, but I'm going to show you what you're going to need to know in order to participate in this course. And then I'm going to show you IntelliJ, and we're not going to use IntelliJ in this course. We're going to use Eclipse. Both of these are really good products. Either one of them is fine for doing Java development. I'm just choosing Eclipse because there's a little bit of a bigger audience out there for Eclipse. There's a little bit more usage of Eclipse, I think, in general. And IntelliJ is a little bit more advanced. I think a lot of beginning Java developers are first going to be drawn towards Eclipse, and so I'm going to show you that, but I'm not giving a personal preference of one or the other. And then we're going to look at packages, which is a very important concept in Java for separating things out and to be able to put your content into different areas so that you can organize your code. And then finally, we're going to talk a little bit about the Java class libraries. I said Java is big, and in this section you'll see just how big Java is as we start talking about all the things that exist in the Java platform. So let's talk about Java. Well, what is this Java programming language? It was initially based off of C and C++. If you start to look at the syntax and the Java source code, you'll notice that Java looks a lot like C or C++. It's very similar in a lot of the constructs, a lot of the way that you program it is very similar. It's basically designed to be written once and run anywhere. What that means is that you should be able to write your source code in one place and in fact compile it, and then that compiled code should be able to run on any operating system that has a Java virtual machine. And that's kind of one of the design goals of Java. And it's also one thing that makes it really unique as a programming language. It runs on a virtual machine. If you're familiar with C# and .NET, that also runs on a type of virtual machine. The Java virtual machine is designed to be cross-platform, but Java is basically a language designed to run inside a virtual machine. As I said, it's similar to C#. It's going to be a lot of the language constructs. You're going to see an exact mirror in C# if you're familiar with C# and vice versa. So a lot of what you can do in Java is what you can do in C#. C# is probably a little bit bigger as a language in terms of what you can do than Java. So Java's got a little bit of catching up to do, but Java is a very robust language. Java is object-oriented. That means that the main focus of the development is to classify things, to organize them into classes and objects. And Java is statically typed. It is not a dynamic language. It is almost a dynamic language in the fact that it is compiled down to bytecode and that bytecode is interpreted. So it is technically an interpreted language, but it is statically typed. It's statically compiled. The compiler looks at the types, and the types are defined in the source code when it's compiled. And really, one important thing to know about Java is that it's a platform. It's not just a language. So when you're talking about Java and you're talking about the features and you're comparing Java, really, it's all of the things that Java encompasses, from databases to security to file I/O to network and all the platforms involved. So Java is really just a huge platform of technologies where the language is kind of the central part of that technology. So let's go through some of the history of Java. It's a language that was developed by James Gosling at Sun Microsystems, so that's where it was born, essentially. It was released in 1995, and it was a drastic change. There wasn't really a language like this before, a language designed to run on multiple machines that runs inside of a virtual machine. It was actually targeted initially for interactive television sets, which was way beyond its time in 1995, and then it got retargeted for the web, which seemed to be a pretty good fit, especially with Netscape coming out and Netscape supporting Java running inside of it through the use of applets, which we don't really see that much today. If you look at the release schedule, you can see that there's been a lot of releases of Java, and it's kind of been renamed and rebranded a few times here. The big thing that happened was with the Java 5 release, there was a lot of actual language changes. Before the Java 5 release, a lot of the other releases really expanded the platform, added more features, but the language changed in 5. So if you're working in some legacy Java code, from 4 to 5 is where you'll see a lot of different changes. And in Java 7, we've added a few more language changes, but nothing too drastic. And then Oracle actually acquired Sun, which of course was the originator of Java. And so Oracle really is kind of the steward of Java nowadays. So let's talk about virtual machines. And one thing that you're going to want to know is how a virtual machine works and what is a virtual machine. That's really going to help you in programming Java to understand the concepts that are involved in running your Java source code, running your Java programs. If you look at this diagram here, you can see that I'm showing several different operating systems. And this could be, you could have Windows, Linux, Mac. You can think of those operating system blocks as those operating systems, or really any operating system. Top of them is a virtual machine. This would be your Java virtual machine for Java. And you can see that each operating system has its own virtual machine. But if you look at the top there, you have your Java source code. It gets compiled by a Java compiler, and that compiled Java code can run on any one of those machines. So basically what's happening here is you're writing your source code once. You're not doing any differences for the different platforms. And there's of course some exceptions to this rule, but the design of this is intended to be such that you write your source code once. In fact, not only do you write it once, but you compile it once. This compiled Java code is actually interpreted. It's like an assembly language for these virtual machines, and the virtual machines are acting to make the same thing work in the different ways that operating systems handle things like files and networking. And so really you're writing your code against these common Java libraries using the Java language, and the virtual machines are handling the differences to produce basically the same output on each operating system. So that's the basic idea of a virtual machine, is that it's virtualizing the operating system. It's virtualizing your application so that it can run on any operating system, and it doesn't have to be written specifically for that operating system. And that's kind of really the key advantage of Java. So a little bit more about the JVM. It's basically an abstraction layer. We talked about how the virtual machine, or how a virtual machine basically lets you abstract away or run your application on multiple operating systems and have them run the same way without having to create a different source code or do ifs inside your source code based on the operating system. You could just write your code in one way and target against the Java framework, and that the virtual machines would handle doing that thing, or rendering that view, or rendering file IO or network operation for you in that operating system. So it's an abstraction layer so that when you're programming in Java, when you're thinking in Java, you're thinking about the Java framework and you're not thinking about what operating system it targets. The other important thing about the JVM is that it doesn't run Java source code. It doesn't compile it. The Java source code is compiled ahead of time. It's compiled into .class files, which are basically bytecode. And bytecode is nothing more than really an assembly language for the Java virtual machine. So just like computers, an x86, a Intel PC basically would have its own assembly language, the Java virtual machine has an assembly language, which is the bytecode. And because of this, you can actually run more than just Java in a JVM. There's a whole host of languages that exist now that compile themselves down to Java bytecode and therefore can be run inside of the JVM. So really, this idea of bytecode is abstracting away, helping to abstract away the operating system so that you can run on multiple operating systems, but it's also abstracting away to some degree the programming language. And you'll see a similar thing if you're familiar with .NET. It's a very similar concept, except .NET wasn't really designed to go for different operating systems, but it does allow different languages. The JVM does garbage collecting, and we're not going to go into detail in garbage collection, but garbage collection is basically a way that you don't have to manage memory yourself. And the JVM is really what's allowing this to happen. As your code is being run and you're creating new objects and you're asking for new memory, the garbage collector is running in the background in the JVM where your application is running, and it's determining which things are no longer being used, and it's freeing up that memory for you. So this is a really important concept that a virtual machine provides to you and that the JVM is doing. So if you're familiar with C++ and allocating your own memory and freeing it up, Java frees you from having to do that. And the other thing along with that, by running in a JVM, is you have some safety. It's kind of a sandbox. A JVM is going to do things like verify that the code doesn't violate its memory or address spacing, that it's not going to be able to just access some random part of the operating system. Things that are running inside the JVM are sandbox. They have that safety because the JVM's enforcing that safety. Whereas if you're running just a native program, there's nothing to stop you from overwriting some memory location that doesn't belong to you, unless the operating system itself has that control. But inside the JVM, you're guaranteeing that safety. So let's go ahead and jump right in creating our first Java application. And so what we're going to do is we're going to create a Hello World application, the basic program that you create when you first learn a programming language, just to show that we can actually compile and build our application and we can print Hello World to the screen. Now, before we do this, what we're going to want to do is to make sure that you have the JDK installed. And in Java, you have a Java Runtime Environment, or the JRE, and a JDK, which the JDK is for software developers. It has the compiler in there. So you need to make sure you've got that installed and downloaded. If you don't have it installed, you can just search for JDK, and it should take you to Oracle's Java SE downloads page. And here you can see the latest version is Java 7. You can use Java 6 if you want, but I'd recommend just go ahead and grab Java 7. And you want to download the JDK and pick the appropriate version for your operating system and run that. Once you have the JDK installed, what you're going to want to also make sure that you have is that you have Java in your path. And if we go into your environment variables on your PC under Advanced System Settings, you should see that you have a path here. And what you're going to want to do is to make sure that Java 7, if you've installed Java 7, is the first thing in your path, because there may be another Java executable that's under your System32, and the way that the path works is that it picks up the first one that gets loaded of something. So you want to put this into your path so that you can compile from the command line. And typically you're going to find the Java install under your program files, Java, JDK 1.7 or 1.6 if you installed 1.6, and then bin. And you just want to take that entire path and put that at the beginning of your path, and then of course a semicolon at the end of that so that the rest of the path can still work. Once you've done that, you can test this out to make sure that you have it installed correctly by typing Java and then -version. And you should see if you have Java 7 installed or 1.7, you should see that. And you should also be able to test Java C the same way to make sure you have the correct version. Those should match. If they don't match, then you've got a problem with your path. So what we're going to do here is we're going to go ahead and create Hello World, and I'm just going to do this in Notepad just to make this as simple as possible, and then we'll get into an IDE a little bit later. So I'm just going to type Notepad hello world.java. And what we're going to do here is we're just going to create our Hello World class. So we're going to create a class called Hello World. All Java programs have to have a class. It's object-oriented. Everything has to be inside of a class. So what we're doing here is we're just creating the basic class that our main is going to live in. And if you're familiar with C or C++, virtually all programming languages have some kind of entry point. Our entry point is going to be a public static void method called main. And if you're not familiar with these concepts, don't worry about it. I'll explain it later. If you are, then this is the method that you need to create. Don't worry if the syntax is not familiar to you. And we're going to take an array of arguments. These are arguments that would get passed in from the command line. And then from inside here, we're going to do system.out.println hello world. And what this is going to do is going to create a class, which is a basic module or unit that we use to divide our program up. And then inside there's a method here, which is basically a set of instructions that the computer is going to execute. And we have this special syntax declaring it. And then inside here, this is a method call that we are telling the computer to print the line hello world. Fix that. So I'll go ahead and save this, and let's go ahead and run this and see what happens here. Now the first thing that we're going to need to do is to compile this program. So I'm going to call javac, which is the Java compiler, and I'm going to type hello world.java. And now you can see it's compiled because there's no errors here, and if we look in this directory, you can see now there's a hello world.class file. And if I were to notepad this hello world.class file, you can see it's not very friendly for us to read. This is the bytecode for Java. This is what the JVM can understand. So now we can actually run Java, which is basically running the JVM, and we can type hello world, not hello world class, just hello world. It'll find it inside the class path. It'll be able to find our program, and it will run that. It will use this class as the main entry point, and then it will run that main method. So let's take a look real quick one more time at our hello world.java file. And you can see here, this is the basic skeleton of a program. You have to have a class. So we've declared our class here. It's called hello world. Inside here, we have to have an entry point, and our entry point is a public static void method named main. It's okay if you don't understand what this is right now. We'll explain that as we go further into the class. And then what we're doing inside our method is we're just printing out the text hello world. So that's it. That's the basic Java program, the basic, most simple Java program that you can create. And we're going to do the rest of this class inside the IDE inside of Eclipse. So now that we've been able to compile a Java program, let's take a look at the IDE that we're going to use for the rest of this course. You can go to eclipse.org and then go to Downloads. And then from here, you can download the Eclipse IDE for Java developers. And you can choose the 32-bit or 64-bit version. Just make sure that which version you choose corresponds to the version of the JDK that you had installed for Java. These have to match, otherwise it's not going to work. So once you've downloaded this, you're basically going to extract the contents to a folder. And you can see here that I've got my Eclipse under Tools, Eclipse. You don't have to actually run and install, you just can run the eclipse.exe right from here. So I'll go ahead and run this. And Eclipse is basically a free IDE. It is one of the older Java IDEs. It's completely open source, and there's just a lot of plugins for Eclipse. When I'm teaching someone Java or another programming language that can be done inside of Eclipse, I typically use Eclipse just because there's so many plugins for it. There's so many people who understand Eclipse. We're going to go over another popular IDE and talk about that a little bit called IntelliJ. Some people might argue that IntelliJ is better or Eclipse is better. It doesn't really matter because they're very similar, and they can both do most of the common features that you would expect in a modern IDE. So whichever choice that you like. If you want to follow along for this course, I'd recommend using Eclipse, but you can use IntelliJ if you want. So let's take a look a little bit about the features of Eclipse here. And I've got a program here that I've loaded up just as a demonstration project here. And you can see that the way Eclipse is divided up here. You've got a lot of things going on in Eclipse. It can be a little bit confusing at first, but we're going to kind of learn this as we go and kind of stick to the basics here. On this left-hand side, you basically have what's called a package explorer, and I'm going to explain packages a little bit more later, but it basically allows you to navigate the source of your application. In the middle here, you've got your main code window, and this is where you can actually do your development, and Eclipse gives you full IntelliSense support, so you can hit dot and then you can see what your options are on objects and methods. It really helps you to code. On the right you have an outline. This is in the default Java view of the methods that exist, and you can jump to them. And then at the bottom you have your console. This would be where the hello world would be displayed, and you have some tabs here for problems and things like that. The basic thing that you're going to do is work inside of the IDE here, inside of the text editor part, and then you're going to compile and run your application. And one interesting thing about Eclipse is that you don't actually have to continue to build your application. So with Eclipse, you'll notice that this run, you can just run right away. You don't see a compile option here because I have build automatically checked. And this is really nice because it's always ready to go. I can just click run. And we'll go ahead and create a new project in Eclipse so you can see how to do that. We just go to File, then we choose New, choose Java Project, and we give this a project name. We can call this Hello World. It automatically should pick up your JRE so that it knows what version of Java you're using. Here it's picked up 1.7. And then we can leave the defaults here and click Next. So you could add libraries here if we wanted to add additional libraries or other source files. I'll just go ahead and click Finish here. And now you can see I'll close this other project that we had. And you can see we have our Hello World project here, and it doesn't have anything in it. We can easily add a file to our project by going to New and then Class. And then we can create our class. We can create a Hello World class. And then from here we can create our method. And you can see as I'm typing here, if I type in SYS and hold down the control key and hit the space bar, it's going to give me some auto completion here. And so this is kind of useful when using Eclipse. You can just select System here, and when I hit dot, it's also giving me auto completion. And again, with the print line, I can always hold down control and hit space. You'll get pretty used to doing that inside of Eclipse. So now I can choose print line and I can print Hello World. So now we've created the same Hello World program, but inside of Eclipse. And I'll save this and we can just run this. And now you can see it said Hello World. So that's it. That's the very basics for Eclipse. It's a very nice IDE. It has a lot of features. There's a lot of things you can do with plugins. It allows you to debug within here. You can set debug points just by double clicking inside of the margin. And there's a lot of refactoring that you get for free inside here as well. And if you haven't programmed before or you haven't programmed in Java, don't worry, this might seem a little bit overwhelming, but I just want to kind of give you an overview of everything first, and then we're going to really get to the basics, back down to the basics, and go over everything and build up our knowledge of the language from there. So now let's take a look at IntelliJ. So I wanted to show you IntelliJ. It's another very popular IDE from a company called JetBrains. If you're familiar with C# and ReSharper, it's the same company that makes the ReSharper plugin for Visual Studio. It's another very popular IDE. Sun, or actually now Oracle, also puts out an IDE called NetBeans, but that one's really not as popular, I think, as Eclipse and IntelliJ. And really, I could go either way on IDEs between IntelliJ and Eclipse. I just tend to choose Eclipse because I think more people are familiar with it, and I think it's a good place to start. But IntelliJ is definitely a great product. It may even be a little bit easier to use for an advanced programmer than Eclipse, just because it's very powerful. Eclipse, I think, is going to be something that is more broad. There's more plugins for it, and it's open source, where IntelliJ is going to be something that is a more focused product. So we can go ahead and download IntelliJ and just take a quick look at this here. And they have an Ultimate Edition and a Community Edition. The Community Edition is completely free. It doesn't have as many features as the Ultimate Edition. So I've went ahead and installed and launched IntelliJ here. So you can see what IntelliJ looks like. And you can see, just like Eclipse, we can create a new project here. And we can create a new project from scratch. It'll create a Java project for us. And we can call this one Hello World as well. Choose the default here for a Java module. Create a source directory. Now the project JDK we actually have to assign here. So I'm going to select the directory for the Java SDK, which I have under Program Files, Java, JDK 1.7. And so it's found it here. I can click Next. You can see it's a little bit more of a, definitely you can tell it's more of a commercial project. In my source, I can go ahead and create a new Java class, and I'll call this Hello World. And inside here, we can do our public static void main string array. And then we can do some.out.println, and we can type hello world. And you can see some of the things like the autocomplete are a little bit faster. Some of the things are a little bit nicer, a little bit smoother inside of IntelliJ. So I'll go ahead and click run here. And you can see here it's run our Hello World program. It's put the output right here. So this is just another option for you. We're not going to go very much in depth into IntelliJ in this course and in this module, since we're going to be using Eclipse, but I just wanted to show it to you and give you the option of choosing IntelliJ if you wanted to develop your Java applications in IntelliJ. A lot of what we're going to do is not going to focus so much on the IDE, so you could do the course in IntelliJ. But if you get lost, you might want to have Eclipse installed just in case. So let's talk about packages in Java. I think this is a very important concept that I kind of wanted to show you first, because it's going to influence a lot of how we develop our application and just the way that things are going to work inside of Java. So if you look here, you can see back in here in Eclipse that under my source folder I've got a default package, and what this means is that I don't have a package that my class is in. And a package in Java is very much like if you're familiar with C#, a namespace. It is basically a way to divide your classes up. So I could actually create a new package under my source folder, and I could call this, let's say, greetings. And then I could actually move my class into here. And then you can see what's happened here is Eclipse is smart enough to automatically add this package to my file. So my Hello World Java is in this package called greetings. And all that this does is make it so that we can segregate our application up, and also so we don't have a conflict. If some other class was named Hello World, you could have two Hello World classes that lived in different packages. Packages just give you a way to divide that up. It also is very important to understand because this is how the file system is set up in Java. So if we look on disk where this is stored, we can see I'm in the workspace in the Hello World project. If we look at our source directory, you'll see that for every package, there's a folder. So under this source greetings is our file. So this is important to understand because when you're looking for a file on the file system, it's going to be organized by these packages. You can almost think of the package as a folder under your source directory. So you could have different packages, and a common convention is to do something with dots. So you could say greetings.hello, and then you're kind of making a more specific package. And you'll notice here when I did this that Eclipse got angry and said, hey, wait a minute, there's a problem here. The greetings.hello does not match the expected package greetings. That's because of the location of this file on the file system. It's expecting those to match up. And I can do a quick fix here and move it. So now it's moved on the file system. And so it should be okay because it's under the greetings.hello. So that's the basic way that packages work. And they're really nothing more than a way to segregate your classes and to prevent them from having the same name, from not being able to tell which is which. So let's look at some of the Java class libraries. And we're not going to go very in depth here, but I just wanted to give you kind of a big breadth of how large Java is and just some of the things that you can do in Java so you can understand if you wanted to do something in Java that, one, it exists, and two, you can find it somewhere in the basic Java framework instead of trying to write your own or to look for some project or some software to buy. And the way that you access these libraries is basically by importing the packages that come with Java or the Java platform. So you have some things like I/O. You can write to disk, you can write to files, you can read streams, read data, write that data out. Networking, you can do a lot of different network reading and writing. You can do things like interpret a web page or process a web page, make any kind of network request or call. It supports several different protocols, networking common protocols. You have a little bit of math here to do common math operations, collections, and this allows you, and we'll cover this a little bit more in the second part of the course, which allows you to basically do things like create lists, create maps, dictionaries. You have regular expression support, and this is going to be similar to the Perl syntax using regular expression, so it's kind of built into the language. You have the ability to log, graphics and UI. There's several different graphics toolkits that are available that you can use in UI toolkits, and they're somewhat similar, but they're different concepts, and you have a couple to choose from when you're doing Java programming if you're making an application that runs on the desktop. Text formatting, you can do all the standard formatting that you would want to do on date, time, and just regular text processing. XML, there's support within Java using JAXB to serialize and deserialize XML into objects. Remote method invocation in order to remotely call a method maybe on a different server, on another instance of an application, running your code so you can communicate between two different applications. Security, a lot of this is implemented in the JVM, but you can use security features, cryptography, things like that. Databases, there's a large support in Java for accessing databases and using an object relational model to get the data. You can either do raw SQL or you can serialize the database tables into objects. And then of course reflection to allow you to basically inspect the Java code itself and to dynamically load up classes, dynamically create classes, all these kind of things. And there's a lot more than this. This is just the basic overview of all the things that you can do in Java. And we'll be exploring some of these things in the upcoming modules. So let's go over what we covered in this module. First thing we did is we talked about Java. We learned a little bit about the history of Java and the background and what Java is. Basically an object-oriented, statically typed language that runs inside a virtual machine. We learned a little bit about the virtual machine. We talked about what a virtual machine is, how it allows you to abstract away the programming language and environment from the operating system so that you could write your code in one place against one target framework and have it run everywhere. Then we went through and we created our first Java program. We created a Hello World program, compiled that, and we talked a little bit about how the Hello World program works and some of the components of a Java application. Then we went ahead and went into Eclipse, an IDE for developing Java, and we talked about how we were going to use this for the rest of this course in order to do our Java development. And we looked at another IDE for Java development called IntelliJ, which is equally good, if not better than Eclipse, depends on who you talk to, but we're not going to use that for this course, but I just want to show you what was out there. Then we talked a little bit about packages, and we saw how packages could be used to group your source code and to make it easier to find things and organize your source code and prevent namespace collisions, naming collisions. And then finally, we went over the Java class libraries. I just gave you a really big view of everything that's out there in Java so that you would have an understanding of what is available and what's possible using Java. And we didn't really go into depth into any of these. We just kind of skimmed over it to see, hey, what's out there? If I want to be able to do something in Java, can I do it? Well, hopefully that's been a good introduction to Java for you. And in the next module, we're going to actually get into some actual Java code, and we'll start talking about variables and operators, and I'll show you how to actually start working with Java language. Hi, this is John Sonmez from Pluralsight, and in this module we are going to be talking about variables and operators in Java. We're also going to be covering a few other topics that are related to variables and operators, and this is kind of going to be the really first steps in learning Java. And before we get really into this module, I just wanted to let you know that for this entire course and for all of these modules, a programming language is something that is really hard to learn from a step-by-step concept introduction style. And what I mean by that is that you may want to go back and review some of these modules as we get further, because I'm going to reference some things in this module, for example, that are going to cover some material that we're not really going to introduce until later modules, because a lot of things in a programming language are very dependent on each other. And so for us to talk about variables and operators, we're going to have to talk a little bit about things like classes and conditional statements. And so when we cover those later on, you might want to come back here to get the full picture. Usually, if you look at a lot of programming books, you'll find that a lot of the books are kind of written this way, basically with having you go back and forth between chapters in order to really get the full concept of it. Now, if you go through the course just one time straight through, you should be able to definitely program in Java, but sometimes to get the real big picture understanding of it, you might want to go back and review some certain parts of certain modules that will start to make more sense to you now as we go further in. So I just wanted to say that just as a caution, so as we're going through here, if we encounter some concepts that we haven't really introduced yet that are going to come in later modules, you don't feel like you're lost, like you need to know this yet, because you don't. It's going to be introduced later, but I need to show these concepts in order to show the examples for some of the things that have to do with variables and operators. So let's go over what we're going to cover in this module. We're going to cover a lot of ground here, and we're going to start with basically defining what a variable is. And if you're new to programming in general, this is going to be beneficial to you. If you already know about programming, we're just going to talk about it in terms of Java. And then we're going to do the same thing with a type. We're going to introduce a type, talk about what a type is, not go too much into detail there. And I'm going to show you kind of how to use a variable in type in Java and how to do some basic declarations. And then we'll talk a little bit about how to name variables. I think it's very important for someone learning a programming language to get kind of some good skills in naming variables, because that really helps you to make readable code. Then we'll cover scopes a little bit, and we're not going to go too in-depth into scopes. I just want to introduce the concept of scopes so that you're aware that variables have scoping in Java. And then we're going to get into primitive types, and we're just going to cover what are the primitive types, what is a primitive type in Java, and introduce that concept. And then we're going to get into somewhat of a complex concept, but I feel that a Java programmer really needs to understand this. So we're not going to go into the really technical details of this concept of boxing and unboxing, but we are going to talk about it, and I'm going to give you an understanding of what it means when someone is talking about boxing and unboxing, and just some of the things that you want to be aware of, how Java operates as a language regarding that subject. Then we'll go into operators. This is something that you're going to definitely need to know in order to program in Java. These are things like adding, choosing whether or not two values are equal or one is greater or less than another. All of the kind of operations that you can do in Java are going to be under this operator section. Then we're going to talk about strings, which are a special type in Java, and we'll go into details on how they are in that section. And then finally, we'll wrap this up by going a little bit into arrays. Arrays are something that is not really a concept that's extremely important in most of the programming today because we use collections, which is another topic that we're going to introduce in the second part of this course. But it's still good to have a knowledge of arrays, and we're going to introduce that here. So let's talk about variables. If you're new to programming in general, you might not really know what a variable is. If you already are programming in another language, you're probably familiar with this term, but it doesn't hurt to go over this concept again anyway. Basically, a variable is just like a variable in a math equation. It's the same thing. If you're familiar with algebra, then you already know essentially what a variable is. And you can see here I've got an example of 1 plus 3 equals 4. There's no variable in there. But if we said 1 plus x, then it's going to be equal to something unknown. It depends on what x is. Same thing in a programming language. And if you think about it, really, if we didn't have variables in a programming language, some way to vary the input or what was stored, programs wouldn't be interactive because they would perform the same thing every time. There would be no interaction from the user. So really, when you think about it, a variable, the concept of a variable is allowing us to have something be changing in our program, and that is really what makes a program interactive. That's at the higher level. Now, at the low level, what is a variable? What does a variable do in our code? It is basically a way that we can store some data in our program. So we can store a number in a variable. We can store a word in a variable. We have a whole bunch of things that we can store inside of variables in Java. When we get into classes and objects later, you'll see that those are also going to be stored in a variable because they can change. And that's kind of the key to a variable, is it's a way of naming something that can change. And really, the best way to understand it is just to think about it as in terms of algebra. It's the same type of thing. And we'll go into an example of using variables in a little bit here. So now let's talk about type. So a type is basically, it represents what that variable is going to hold or what kind of variable it is. A variable can be of many different kinds. Of all of the types or objects that exist inside of Java, each one of those could be stored in a variable, but because Java is strongly typed, we have to declare what that type is. The compiler doesn't automatically know. You probably already have somewhat of a concept of types. If you're programming in another language, for sure you would know what a type is, but if you haven't, you still probably have some concept of types. If you think about it, if I said what type is 3, well, you might say, well, what is 3? It's a number. In Java, it would be called an int or an integer. You can already classify a number, the number 3, as a number. And if I said to you, what type is hello? You might say, well, it's a word. And in Java, it would be a string. So we're already identifying things naturally in the world by their types. If you see a chair, you recognize that and you say, it's a chair. It's a type of a chair. There is more than one chair in existence, but we classify things by type naturally. So that's all that a type is doing. And when you look at that example, when we declared a variable, we said, hey, we want a variable of type integer. That means it can hold a number, and we're going to give it a name. So that's all that a type is. And we'll get a little bit more into the different kinds of types a little bit later in this module. But the important thing to know about types in Java is that Java is strongly typed. And what that means is that once you declare a type for a variable, that variable is always of that type. If we say integer I, that variable I, named I, is always going to be of type integer. And we also have to declare the type. We can't just say, give me a variable. We can't just say, just declare a variable of I, and I'm not going to tell you the type. Instead, we have to say what the type is. So let's take a look at how we can use variables in our code. I've got our Hello World program open here, and I'm going to demonstrate creating a variable, and then we're going to look at the value of that variable. So I'll go ahead and create a variable, an integer, and we'll call this variable number, and we'll give it a value of 3. And then let's go ahead and print out, using println, just like we had done with Hello World, the value of that variable. And println is actually a method that lets us write to the console. We can call it like this with system.out.println, and it'll take a lot of the different primitive types or string and let you print to the screen. So we can print our number out, and it's going to print out 3. You can see here it says Hello World, and then we have 3. And the way that this works is you can see that we have our variable, we've declared the type as an integer, we've said what the name is, and then we've done an assignment and we've assigned it to the literal value of 3. We could also do this with a string. We could say string name equals Joe, and then we could print that out as well. So let's run this and see what happens. Now you can see we've got our Hello World, we've got 3, we've got Joe. So that's really the use of a variable. We could also rename or reassign a variable. So I could change the name to Jimmy, and then you can see that it was first set to Joe, then it changed to Jimmy, and now it should print out Jimmy. We can also do things like assign a variable to a equation, basically, or a statement here. We can say number equals 5 plus 2, and of course we're going to get it assigned to 7 here, and we can prove that by running, and you can see that it's now 7. So really this variable can hold the result of a computation, a string, whatever type that we'd want. Now one thing that's really important about variables that I wanted to cover here is the naming of variables. I think one of the critical things in creating readable code, and really the way that other people judge your code, I know especially when I'm interviewing someone, if I'm going to judge how well they write code, is how well they name their methods and their variables. So naming a variable correctly is very important. You should really err on the side of making your variable name too long or too descriptive rather than non-descriptive. So for example, a bad variable name is going to be something like X or I or Y. I is sometimes used in a counter, but for the most part, you want to name the variable after what it's going to hold. So in this case, when we had name here, even this is probably not as good as a name like, or a variable name like first name, because that's really what we want to hold. So this is more specific, so it's better. So really don't be afraid of how long your variable name is. It's more important to be descriptive and to clearly identify what the variable is for, rather than to try and be short and save on typing. So now I want to introduce to you the topic of scope. And when we're working with variables, scope is fairly important because you're going to need to know what is going to happen with a variable. When you try to grab the value of a variable or assign a value to a variable, scope is really going to influence what happens. And really what scope is just, it's this concept that variables can exist in different contexts. And what I mean by context is that within your code, there's going to be certain sections of the code that are basically a context in which that variable has a meaning or a different meaning or no meaning at all. And if you look at this diagram that I have here, this kind of represents some code. If you look at the green box, that green box might be a class. And we haven't covered class yet, but class is the basic thing that all things in Java must be contained within a class, all of your code. It's a big container. It represents an object in the world. We'll cover this more when we talk about classes. But within that class, you may have some variables that are declared at the class scope. And then within that class, you might have a method, and a method is just a set of instructions that are grouped by a name. And you may have some variables that are declared within that method, and then within that method, you may have some variables that are declared within certain blocks or certain sections of code within that method. So really what you're seeing here is that these variables have a different scope based on where they are declared. And one of the things with scope is that always variables that are from an outer scope are visible within inner scopes, but variables from inner scopes are not visible in the outer scopes. So let me break that down this is the key concept. We don't even really have to go much into depth here. If you understand this, you'll understand how scoping works and all the rules. We don't have to go over each individual rule. But this is the basic premise. If I declare something at the class level scope, that's an outer scope. It's the outside, it's less specific. As we go into the method, the method is inside the class, and maybe the block or the statement are inside the method. So that's the outermost is the class, and then within that is a method, and within that is maybe a block or a set of statements. So from the outside, if you declared a variable all the way up at the top, the class level, inside your method, you'd be able to see that variable. It would exist. You could manipulate it. Inside the block or inside a block of statements inside that method, you would also be able to see that variable. Now, by contrast, if we had declared a variable inside in the innermost block, inside a method, inside a class, if we declare a variable all the way deep inside, you can't see it from the outside. The class isn't going to be able to access it. So that's the idea of scoping, is that variables go out of scope when their block or their section ends, where they're declared. That basic concept or that construct that where they are declared is where they live and they exist, and outside of that they don't. And so since you see that in this diagram, I'm showing that a class has a method which has statements or blocks, the variables from the class exist all the way down that chain. But if you declared a variable inside of a block, inside of a method, it doesn't exist outside of that. So that's the whole concept of scope, and we'll look at some examples. So I've set up a quick example here to show you how scope works inside of Java. And we're not going to go very far into depth here, but I just want to give you an idea of how it looks in the code. So this declaration here is actually creating a variable that is scoped at the class level, at our class level. And don't worry about this syntax here. Just know that this is a variable called age that is at the class level, and it's set to 50. And I've commented out some other lines here, and we can see that if we call this system.out.println and see what the age is, we can see that it is set to 50, just like we had declared here. So this scope, even though we're inside this method, we have the class level scope, the method level scope, and then we're calling this within the method, it's getting that 50. Now, if I uncomment out this age that's declared inside this block, you can see that this is a new concept here for Java, which is a block. And we'll get into this more when we get into conditionals. But basically, any set of statements in Java, any number of lines, can be grouped into a block, and they'll be executed as one statement. So anywhere where you could have one statement, you can have a block instead. A block has its own scope. If you remember from the diagram we looked at, this is inside of a method. It has a scope. So when I run this, what do you think is going to happen? Well, it's still going to grab the 50 because this variable is only going to be in scope. It's only really going to exist from the beginning of this block to the end of this block, which is almost no time at all. So by the time we get down here, it's already gone. And since this scope is more specific, it's an inner scope, we are not being able to access the variable from outside here. So if I run this, you can see it's just getting the 50 here. Now, let's change this. Let's uncomment this one. And this is in the method level scope. So now what do you think is going to happen? Well, in this case, we're still going to be able to see this one inside here by the time that we get to the print line. But this other variable that's in scope in the method is going to basically hide this one because this variable is in scope. It's declared right here in the method. So when we run this, we should get 20. And you can see we've gotten 20. Now let's try one more experiment here. Let's go ahead and move this print line, instead of in here, right into this block. So now it's in this small scope here. Now what do you think that it is going to print? Well, let's look at what's visible from inside here. Actually, from inside this scope, if something was declared at the method level, we would have that visible, and at the class level, that's visible. But because we have something declared right in this block here, it is going to override or hide what is at the class or method level, and so we should just get 25. And that's really how scope works. It's not that complicated of a concept. Basically, variables live from within their scope, and they can always access or be accessed by a deeper level scope, a deeper nesting. So let's talk a little bit about the kinds of types that exist in Java. There are two basic kinds of types in Java, two big classifications. And really what we're going to be concerned about right now is primitive types. But if something is not a primitive type, it is basically a class or an object. And we'll get into classes and objects later. But basically, a primitive type is going to be any kind of type in Java that is not an object, that basically is what it says. So what I mean by that is that a primitive type, if you assign it to something, that value in memory is exactly what you assigned. Whereas objects and classes, other types that are not primitive types, what a variable really represents in Java is a memory location. It's a reference to a memory location. And this is kind of confusing, especially if you haven't done very much programming. You don't really have to understand this concept. I think a lot of people teach this concept very early and confuses a lot of people, but you don't really have to understand exactly how this is happening in memory. But just to know that a primitive type is a special type that has its value exactly represented, and it's not a reference to something else. And as we get more in depth into more advanced Java topics, that will make a lot more sense. But really all you need to know right now is that a primitive type is a special type in Java. And these are basic types. These are the most base types. Primitive types are not types that you create in Java. They're types that exist in the language. So if we look down this list of primitive types in Java, there's things like a byte. And a byte basically stores memory data. It can store a value from negative 128 to positive 127. It's basically a computer byte, if you're familiar with that term. If not, it's okay. The next one is a short, and a short is basically a 16-bit number. And what that means is that that number can store 16 bits of information. So this would be negative 2 to the 15th power, or positive 2 to the 15th power minus 1. Well, basically, the value is negative 32,768 to 32,767. That's how much can be stored in that data. It's really the size of the variable of what it can store. An integer is the same thing, except it's 32 bits. So it's much larger. We're not going to go over all the numbers on each one of these, but it's twice the bit size, which means that it can store an exponentially larger number. A long, you could probably guess, is double the integer. It's going to be a 64-bit number, which is a huge number. But it's a number from negative to positive. It can hold either a negative or positive value. All of these, short, int, long. A float, a 32-bit decimal number. A double is twice that. It's a 64-bit decimal number. A Boolean is true or false. It's a 1-bit value. And a character is a 16-bit character, a character that you would find in the keyboard. It's basically a letter or number. And then finally, the last type that it's not really a primitive type, but it's treated like a primitive type in Java is a string. A string is actually an object, and a string is a sequence of characters. Like when we create our Hello World program, and we said Hello World, that what was in quotes there was a string. So a string is really an array of characters. It's a chain of characters, but Java makes it real easy for you to work with this type because it treats it like a primitive type for all intents and purposes. And we'll cover string as a special case a little bit more later. But this is the basic idea, that these are the primitive types that you have in Java. And if you're using one of these types, the difference is, and we'll get into this a little bit more, is that it is going to have that type directly stored in memory. So when you copy the value, it copies the exact value. Whereas any type that's not a primitive type, it's really the variable is referring to some other memory location, and the value that you'd actually find in that variable is a reference to that memory location. So you might wonder, why did we even introduce primitive types if we don't really need to understand what the difference is so much, and we don't really care about references in memory? Well, it's because I wanted to introduce this important concept in Java to you, which is boxing and unboxing. And you kind of have to understand what a primitive type is in order to understand this idea. And this is an idea that I think a lot of advanced Java programmers might not even know about. It's an idea that really kind of can make people a little bit scared because it seems complicated, but it's really not complicated. Here's the basic idea. We said that we have these primitive types, like an integer or a boolean. Well, each primitive type has a corresponding object. It has a type that is a non-primitive type that is the same thing. So the lowercase int has an integer class. The lowercase boolean has a boolean class. And we talked a little bit about classes. We'll talk about that more later. But basically, it has a non-primitive corresponding type for it. And those types act as a wrapper. So what do I mean by a wrapper? Well, if you look at this diagram here, you can see that I've got an integer. It has a value of 3. And here I've got the big integer, as it's called in Java, or the non-primitive type integer, and it stores the primitive type integer within it. And so it's acting as a wrapper. And so this can be passed around. And the only purpose of this is that there are certain methods, there are certain things that you need to do in Java that have to take a non-primitive type as an input. And if we did not have this ability to have these wrappers, then we wouldn't be able to call these methods. We wouldn't be able to use this functionality in Java. And so that all that we're doing here is, it's called boxing and unboxing because you can imagine this as a box. We're taking our primitive type, we're putting it in a box, and we're sending that box over to whatever method or whatever thing that we're going to call that requires a non-primitive type. And then when it gets it, it might do whatever it's going to do with it and return us some value that's also in a box. And then we take our value out of the box, and now we have the primitive type that we can use again. And a good way to visualize this is, let's say that you wanted to ship some baseballs to someone on the other side of the country. Well, you couldn't just go to the post office, take 5 baseballs and say ship this. You need to put it into a box first because the post office doesn't operate with round objects. They don't really ship baseballs individually, right? You would have to box it up, take the baseball, put it in a box, and then you can ship it. And then let's say that someone shipped you one in return. Well, they wouldn't ship you just a loose ball. They would ship it to you in a box, and then you'd pull it out. And so this is the same concept here. It's just the certain methods or certain things in Java require a non-primitive type. And because of that, the primitive type needs to go into a box so that it can be given to that method. And then you can take it out of the box when you need that value back out. Now, Java will do this automatically for you. As we'll see when we actually get into some method calls, when we pass a value through a variable, Java can automatically take an integer, and it knows that if this method requires a non-primitive version of the integer, it can automatically auto box. It'll put that integer in a box and then use it. And the same thing will happen if you try to assign a value out that is in a big integer, in the box integer. And your variable is of the non-box type, the primitive type integer, it's going to unbox that automatically, so you don't have to do this. You don't have to do anything. The reason why this is important is you need to understand this is going on because it can be a costly operation to do boxing and unboxing, especially if you're doing this in your code where you have some kind of loop and you're doing a lot of operations that are requiring a lot of boxing and unboxing. And kind of where this happens is more of an advanced topic, but I just want to introduce this concept to you so you know what's going on when someone's talking about boxing and unboxing. So let's take a look at some of the operators that exist in Java. And an operator basically is just something that goes in between two variables or two things inside of a Java statement. And a good way to think about this is we already do this in arithmetic, in any kind of math. We already have operators that we use to add numbers together. It's the same concept here. In Java, in fact, we have math operators. And I'm going to go down this list. I haven't included all the operators here. I've just included a lot of the basic ones. So this is not all the operators that exist, but it's the ones that are the most basic. For someone learning Java, you're not going to need to know every single thing. I'm trying to reduce this set down. So the math operators, you can see here, these are basic ones that you're probably already familiar with. Subtraction. If you use a subtraction operator, you can say 3 minus 2, and then the response that's going to come out is going to be 1. Same thing with plus. You have a multiplication. If we go down the line here, you'll see there's 2 division operators. One of them is a whole number division, and the other one is called modular or modulus. And what this does is if you take, for example, 5 and you use the regular division sign, the slash, divided by 2, the result is going to be 2 because it's only going to give you whole numbers. It's so that you're not having something that was a whole number type and converting it to a decimal. That is if you're working with whole numbers. If you're working with a decimal type and you do the regular division, it's going to give you a decimal number. But if you're working with integers or whole numbers, it's only going to give you a whole number back. And that's why that second modulus operand exists. That operator, it looks like a percent sign. If you said 5 mod 2 or 5 divide 2 using that operator, it's going to give you back the remainder, which is going to be 1. So a little bit confusing if you're not familiar with the concept, but it's basically the 1 gives you back the whole numbers that go in, and then the second one, the modular one, gives you back whatever the remainder would be if you're doing long division and you got a remainder. That's the value. Next down the line, you see this weird plus plus and minus minus. All this does, these are called increment and decrement operators, and if you put this at the end of a variable or a statement, it will make it so that that variable gets incremented. So if you had a variable x that was equal to 1 and then you did a plus plus, it's now going to be equal to 2. And if you did minus minus, it would be equal to 0. So it's just basically a shorthand way of incrementing or assigning that variable, whatever it was, plus another, or whatever it was, minus another. And there's a version of this where you can do this before or after a variable. And we're not getting into the specifics of that right now, but just to know that you have that ability. So the next set of operators is assignment operators. And we already seen some of this in usage. We already use an assignment operator to assign a value. When we said int x equals 3, we use this equal operator, and that allowed us to assign a value to a variable. This is how we give a variable a value. And then you have all these weird looking assignment operators. You have a plus equal, a minus equal, a multiplication equal. All this does is this is another shorthand, and this is a shorthand for saying take my value and then assign it to whatever I put on the right hand side of this operator, plus whatever it was, or minus whatever it was, or multiplied by whatever it is. And so this is just a shorthand. We can write out the plus operator for example, the plus equal. If we said x plus equal 3, it's going to be whatever its value was plus 3. So we could rewrite that as x equals x plus 3. It's just a shorthand, but we have all these operators for each one of the corresponding math operators. Next is relational operators, and these operators are going to compare two things. And as we get into conditional statements, then this is going to make more sense. But for now, we're just going to overview what these operators are. What it basically lets you do is to evaluate whether two different numbers or variables or types and see is one greater or less than the other, are they equal, are they not equal. And this is going to be important when you want to choose something, when you want to say, if this number is greater than the other one, then I want to do this. Or if this number is less than the other one, then let's stop this loop. So you can see that these probably already make sense here. A lot of these, you have a greater than symbol, a less than symbol, greater than or equal to. This is true if it's greater than or equal to, a less than or equal to, and then this equal equal. This is a true equal. And the reason why this exists in Java is so that assignment doesn't get confused. So when you see an equal equal, it's actually asking the question, are these two equal, rather than saying, I want to assign this value. And then the last one is not equal, and this is asking whether or not these two values are not equal. It's true if it's not equal. It's the opposite of the equal equal. Finally, we have logical operators, and once again, this we'll go through a little bit of an example of this, but you have your and, an or, and a not. And the first one, the two ampersands, is an and it works just like logic. If you're taking a logic class, or you're familiar with logic statements, truth tables, it's the exact same concept here. If you have a variable that's equal to true and you apply an and to it, or an and to a variable that is also equal to true, the result is true. If you had a variable that was equal to true and you say and another variable that was equal to false, it's going to be equal to false because they both everything has to be true for an and statement. The or, either one can be true. So if you had a variable that's equal to true, put the or in between, and you had another variable that's equal to false, the result is going to be true. The only way an or is not going to be true is if both sides are false. And then the not just reverses whatever the value is of a variable. If you had a variable that was equal to true and you put a not in front of it, it would now be equal to false. If you had a variable that was equal to false and you put a not in front of it, it would be equal to true. And these apply only to Boolean types of variables, which a Boolean type is one that can be either true or false. So now let's take a look at some of the operators that we had covered in the slides. Well, let's look at some simple cases first. We'll create a number and set its value to 3. And you can see here that we have actually used an assignment operator. This equal assigns the number. We've already seen some usages of the math operator. We can assign our number to 3 plus 2, which would be 5. We could assign our number to 5 minus 1. We can do multiplication, division. So the basic math operators. We can also take our number and do plus plus, which would increase that number. So if we were to look at what that would do here, I'll go ahead and print out what our number is after we've done the plus plus. You should see that it is now 4. So that's all that the increment operator does, and we could also have used the decrement operator as well. We've already seen the assignment operator, but let's take a look at how one of the more complicated assignment operators works. So for example, we can do number plus equal 2. And what this is going to do is it's going to be the same thing as if we had typed number plus or equals number plus 2. What's going to happen is it's going to take our number and it's going to add 2 to it. It's basically like an increment operator, except that we're specifying what to add to it. So if we run this now, we should see that our number was 3, it added 2, so it'll be 5. And the same thing works for multiplication, division, subtraction. So now let's take a look at some of the relational operators. And what we can do here is, in Java, we can print out the value of a Boolean. So I'm going to create a Boolean called value, and we're going to set this to true. And then I'm going to print out the value of this Boolean. I'm going to print value. Let's see what we get here. We get the word true because it's true. So this allows us to test some equality operators. We can check to see if numbers are equal or not. We can do this right inside of our print line. So let's take a look at, if I do 3 is greater than 2. Is this true or false? It is true. We can do the same thing here. 3 is less than 2. That will be false. And then of course we could change this to greater than or equal to. And if we put a 3 here, then this is going to be true. Less than or equal to, we can see if 3 is equal to 3, which is true, or 3 is not equal to 3. And you can see that that is false. And this really isn't going to be very applicable to right now until we actually get into conditionals. But if you can imagine, we're going to get to a place where we're going to want to do something if some variable is greater than another one or equal to another one or less than another one. And that's where these operators will really come in handy. And we can test out the same thing with the logical operators in the same way. So we can check to see if we said true and true, what will this equal? Well, this should be true. And if we said true and false, since one of these is false, the result is going to be false. They both have to be true in order for it to be true. And we can try the OR operator. Now if we said true or false, if either one is true, it'll be true. So we have true. And if they're false or false, since both are false, we're going to get false. And the not operator just does the opposite. So if we had a false and we put a not in front of it, we'll get true. And if we have a true and put a not in front of it, we're going to get false. And we could put a not in front of that, so it's not true, which would be true. So let's talk a little bit about the special type in Java, which is a string. And a string is a special type because it is treated like a primitive, even though it is actually an object. And it's really not important as far as how that works. What this really means is that you can use this anywhere that you can use a primitive type. It acts like a primitive type. It can be just assigned without using the new syntax, which we'll cover a little bit later when we get into classes. But one other important thing about a string is that they're immutable, which means that they cannot be changed. So when you create a string, you initially create that string, like you can see in this example below. We have a string called salutation, and we have it equal to hello world. If we were to later change that, if we said salutation equals 123 for hello, it's actually going to create a new string in memory. It's going to appear to us that we've changed it, but it has actually created a new string, because you can't change a string once you've created a string. And that's where you can see that it really is an object, because if it were not a reference, if it were the actual value, then we would have changed it. But because that variable actually points to some memory location, we can actually assign it to a new memory location. It actually creates a new string. And Java really makes it easy to work with strings. That's the whole point of this, introducing this concept of strings, is that we'll see some examples how you can do some string manipulation in Java, and Java has just made it easier. If you look at the example below, we saw that the easy way to declare the variable called salutation that holds a string is to just say equals, in quotes, hello world. You could also use the syntax of new string and create an object, but Java makes it easier for you, so you don't have to do that, because it's a very common thing to use strings in Java. So let's take a look at some of the things that we can do with a string in Java. So if you remember, we can declare a string variable just by typing the word string, giving it a name. We'll call this first name, and we'll set this equal to John. Now, some of the interesting things that we can do with a string in Java is we can, of course, just print out a string. So let's make sure that we're able to print this out. And we can also, remember, we can't modify a string, but we can add some strings together and it'll create a new string. So I can use the plus operator to actually add strings together. So I can set first name equal to first name plus space Sanmez, and I'll add my last name onto here. Of course, the variable name is not very good anymore, but you can see that I'm adding two strings together to get a third string, which we're assigning back to the first name. In fact, why don't we just create a new string here, and we'll call this full name. So now the full name variable is equal to the first name plus the last name. And if I print this out, you'll see that it is equal to both of those strings added together. Another interesting thing that we can do with strings is, because strings are actually objects, we can actually get the length of a string by calling methods on the string. So we can call the length method, and that will spit out the length of the string. We can see that it's 11 characters long. And we can also find out where a letter is in the string by calling a method on the string. We can call dot index of, and we can pass in a character or even another string. And for this example, let's pass in the character Z. And you can see the special syntax I'm using to use a single character, which is single quotes. This is something that Java interprets as a single character. A string is always in double quotes, but a single character, if you want to treat it like a character, is in single quotes. So we're going to find out what index or what number count starting from 0 would the Z be in this string. And you can see here it's the 10th. So 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the last thing I want to show you is arrays. Remember, I had said that arrays are not so important nowadays inside of Java, because we mostly use collections, which we're going to get to in a later module. But you still need to know what an array is, and occasionally you will still have to use an array. An array is basically just a way that we can have a list of a size that we know of some variables, and we can give that list a name. And so I've got an example here where I am declaring an array of numbers. You can see here I use this special syntax with these brackets here. This is the type. This means I have an array type of integers, and then I've called it numbers, and I'm assigning it and you have to use this syntax of new int, and I specified the length. So the length here is going to be 10. So this is going to create an array of 10 integers. Once you've created your array, you can assign the different values in the array. So in this case, I'm assigning numbers 0 equal to 5 and numbers 1 equal to 8. Now, this is 0 index, so what that means is that within this array, it's going to be 10 numbers starting at 0, so 0 through 9. And I haven't initialized all of them, I've just declared 2 of them, but we can get those values out of the array. What you're using here is a special syntax called an indexer, and this allows you to index into the array in Java. So let's go ahead and print out some values of the array to see what they are now. So I can use this print line again, and I'm just going to print numbers 0, and we're expecting that should be equal to 5. And you can see it's printed 5 here. If we checked numbers 1, we would see that was equal to 8. And what do you think will happen if we choose numbers 2? We haven't declared it here. You see that it is actually equal to 0 because it initializes as the default value for an integer is 0. So that's it. That's an array. You can also notice here that we're using an array already in our main entry point into our application. The strings that come in, this is an array of strings, are the command line arguments that come in if you're to run this program from the command line. Now, one important thing about an array in Java is that once you've created this array of a size of 10, it cannot be resized. You'll have to create a new array and then reassign the numbers in that array. So this is one of the reasons why typically nowadays arrays aren't used as much as collections, which can be resized. You can have basically arrays that are dynamic in size using a collection. But it's important to know what an array is, and occasionally you will still have to use an array when programming in Java. So let's go over what we covered in this module. Well, the first thing that we did is we talked about a variable. I introduced the concept of variable. And along with that, we needed to know about types. So I showed you what a type is and how you could use a variable and using a type to declare the type of variable and assign that variable. We saw how to do that in code. Then I talked a little bit about naming variables. We talked about how important it is to choose a good name for a variable because it makes your code a lot more readable. Then we went through scopes, just briefly, just to introduce the idea. We didn't go into details in scopes, but this idea that basically variables can exist in different contexts, and you might not be able to access a variable from a higher scope than what it was declared in, a higher context. And we talked a little bit about the primitive types. We went over all of the primitive types, really in order to understand this concept of boxing and unboxing. And we talked about how you could basically think of boxing and unboxing as if you want to ship a baseball to someone across the country, the mail service doesn't ship round, single, loose baseballs. You need to put it in a box, and then you can take it back out of the box and then actually use it. Same concept in Java. And then we went through the basic operators that exist in Java. We didn't cover all of them, but we covered most of the basic ones that you'll use. We talked about strings, the special case of strings, and saw an example of doing some string manipulation in Java. And then finally, we briefly covered arrays, and I showed you how you could declare an array and use an array in Java. So let's go over what we're going to cover in this module. Well, the first thing that we're going to do is we're going to answer the question of what is a class. We're going to define from a very high level what a class is and try to really understand what a class is in object-oriented programming and specifically in Java. Then we're going to take our understanding of a class and we're going to use that to define an object. We're going to see what the difference between an object and a class is, because this is a really important distinction that you need to be able to make in Java. A lot of people get confused between a class and an object, and I really want to clear this up so that we have a good solid understanding to build from. Then we'll talk about how to make up a class, which is to use members. We'll talk about how members are the data and the methods that operate on a class, the data and then the way to manipulate that data, and how that is tightly bound together in a class. Then I'll show you some examples of how to use a class. We'll create a class and we'll create some members for that class, and then we'll see how we can create an object from that class. Then we'll talk about how to create methods and what a method is. I'll show you how to create a method on your class and the different kinds of methods that you can use in a class in order to manipulate the data in a class or to access that data. Then we'll get into some constructors. As we create our class in Java, we'll find that we need some way to initialize that class or to set its default values or to set some values on that class so that the object that gets created from that class can be used. And I'll show you how to do that by using constructors. Then finally, we'll get into access modifiers, which will allow us the capability to hide data in our class or to make it visible. So let's answer that question that many of you may be having is, what is a class? Well, to put it really simply, it's a way that we classify things in Java. And you see all these printers that I have on this slide. The printers are a good example of something that we already do in normal day-to-day life that is very much like a class in Java, which is we have a large number of printers that exist in the world. They have all kinds of different attributes, whether they have a duplexer or different paper sizes that they will print on, or color, or black and white, or model numbers, or manufacturers. But we typically would just say, hey, I want to buy a printer, or I have a printer. We don't necessarily go down to all of the details. And when we talk about a printer, someone understands what we mean. They understand the general idea of what a printer is. We don't have to tell them exactly what the attributes are for someone to understand that we're talking about a printer. And when we try to build a printer, we generally know what a printer needs to do. There's certain things that all printers have in common, and that is kind of a classification, and that's really what a class embodies in an object-oriented programming language. It's a way that we're trying to take something, a lot of times from the real world, but in today's object-oriented thinking, it's not always from the real world. What it's more of is a set of responsibilities and some data that we are grouping together to classify something so that we can create instances of that thing and have the data vary. We're basically taking out what is constant about a thing and using a name for it so we can identify that. And so with the printer example, if you think about it, when we say printer, well, what are some of the common things about a printer? You think that it has a paper feed, it has cartridges, depending on what kind of printer it is, but it has some ability to print, some kind of printing engine. It usually has an on and off switch. These are the kind of things that all printers have. So when we're thinking about a class in Java, it's really just this structure to define this classification of a thing. And so now let's look at a little bit more of a technical explanation of what a class is in Java. Basically, a class is methods and data. And what I mean by that is data, of course, is things, attributes like a model number or a serial number or a paper capacity. It's data that can change about a printer. Different printers might have different data. And methods are actions, are things that can be done with a printer or on that data. So a class is a way that we're going to group together this related set of actions or things that manipulate data and the data itself. And that's really the key. You can use a class in a different way than that, but the real reason for creating a class and a thing that makes a good class is how tightly bound together the methods or the actions and the data are. You want to put them together so that they perform as one action. And so a class, basically, another way of thinking about this is a blueprint for creating an object. So up to this point we hadn't talked about objects, and we're going to talk about objects a little bit more later, but basically a class is going to act as a blueprint, or you can see here I've got another example is cookie cutter. And that class is going to be the mold or the design that's going to allow you to create this other object that's more specific. So when we think about this in terms of the printer, if I said I have a class called printer, well, that's not very specific. But you want to be able to create something specific. And what you want to know when you create something specific is the important details, the things that make printers different. So what are the things that make different printers different and what things are the same. The methods and data that are common to all printers, and that's part of the class. And then when we talk about what makes them different, that's going to be where we get into the objects. And what a class is doing is it's allowing you to specify what are the general characteristics of a printer so that you could actually create a printer in your code. So another way to look at a class, getting even more into the technical details of what a class is in Java, is it's a type. A class is a non-primitive type. So what I mean by that is we had covered primitive types before, integers, the decimal representations of floats and doubles, and a Boolean, characters. A class is none of those. What a class is it's basically a type that you create, or that is created even by the Java class library. But typically when you're using classes or you create a class, you're basically creating a type. So if you declare a variable can be instead of a type we did integer x equals 3, you can have your type or your class be that type. So if you create a printer class, you might have printer x equals, and then you would create a new printer. So there's a way that we can think about this also, of why do we have a class and how does this whole type system and classes work together. And that is basically, if you think about that in Java, everything is eventually made up of primitive types. You have to have everything that exists in Java, in a Java programming language, at some root of it is a primitive type, an integer, a character, a decimal. And a class is just composed of those primitive types and then some methods to work with that data. So when you think about it, what you're doing with a class is you're herding complexity. You're taking something that's complex. You could take any Java program, you could get rid of all of the classes, and you could just use primitive types and not group them together. It'd be really hard to understand that program because it'd be very complex. But you could do that. And if you think about the contrast of that, what we're doing with the class is we're taking that complexity, we're grouping it into roles and responsibilities, data that belongs together, and methods that work with that data. And that is really what we're doing when we're creating a class. So now that we've talked about what a class is, let's define an object kind of in terms of a class. So what is an object? The simple definition is it is an instance of a class. And what I mean by an instance is if a class is a blueprint, an object is a house. It's a thing that you build with the blueprint. If a class is a cookie cutter, an object is the cookie. So if you think about it that way, the class kind of set these parameters. With our printer example, the class was a printer. The object is a very specific printer. It is your printer that is in your house, sitting on your desk with the model number, a serial number, all of these attributes. It's no longer this intangible thing. A class is intangible. An object is a real thing. It's an instance of a class. It was made by the blueprint, the mold that the class provided you. So another way to think about this is a purchase in a store. Now, if you went to a store and you said, I want some candy. Well, that's not an object. Not candy. Candy is a class. If you just said, I want candy, the person selling the candy might say, you need to be more specific than that. I want a specific type of candy. Well, that's still not even good enough of a definition. That's still a class, because you might have this idea of, I want a candy bar, or I want a Hershey's bar. You can't buy this concept. You can't just buy candy, or you can't just buy a Hershey's bar. You have to buy a specific actual candy bar. So if you're really going to the store to buy candy, you'd pick up a candy bar, you'd put that on the counter, and you'd buy that, and that is an object. And so when you think about it that way, that's how you can really separate a class from an object. A class is the idea. An object is the actual real thing. And when we're talking in code, it becomes a little more blurry because, of course, everything is in memory. But the real way to think about it is you can kind of run through that test and say, is this thing something specific, an exact, one-of-a-kind, unique thing, an instance, or is it this general idea? Class is a general idea, an object is a real thing. So now let's talk about members. Members are basically the way that we define a class. If we wanted to create our printer class, it's not enough just to say, hey, we need to have a printer class. what you need to do is to define what makes up that class. What data does it have? What kind of actions can you do on that data? So what we call these things, the data and the methods that make up a class, are members. And if we look at our printer example again, we can see that here are some things that might be considered data. The model number, a manufacturer, the sheets of paper that are loaded, whether it's color or black and white, whether the printer is currently on or off. Things like that, all of the attributes that would be specific to a printer, not just a printer like your printer sitting on your desk, but the current even state of that printer. These are the things that are considered data. Then the other half of this is methods. In order for you to have a good class, these methods should work with that data or operate on that data. So let's look at some examples here. Some methods might be print. All printers should be able to print. You should be able to turn them on or turn them off. Show some kind of error where there's a paper jam, whether you have an LCD display or flashing lights. Somehow you need to be able to show an error. So this is just kind of some simple examples, and we'll get into the code of how you do this. When you think about creating a class, you want to think in terms of data and methods, and those are going to be the members that exist inside of a class. So I've got our Hello World project open, and now I want to show you how we can actually create a class. So what we're going to go ahead and do here is we're going to create a new printer class, just like we had talked about in some of the slides, and we're going to see how we can actually create that class in Java. So using Eclipse, it's pretty easy to do this. I'm actually going to create a new namespace for our class. I'm going to go to New Package, and we're going to call this Printing. And actually, the Java syntax is usually to have these start with the lowercase letter, so we'll set this to printing. And then from inside here, I'm going to click New, and then Class, and I'm going to create a class called Printer. And I'm going to leave everything default here, and then click Finish. And you can see it's created a class called Printer. And the details of this public is not really important right now. We're going to cover this a little bit later when we talk about the access modifiers. But you can see we have our printer class here. And the basic thing that you need for a class is basically just this access modifier, the word class, and then the name of the class. And that creates a class. And because it has this package printing here, it's putting it in the package that we had defined of printing. So within this class, some of the things that we're going to want to do is define some data members and some methods. And for now, we're just going to create a very basic class that just has some data members. So what I'm going to do is basically just create some variables that are class level variables. Before we had worked with variables, we had created variables that were method level variables. In this case, we're going to create a class level variable. So I'm going to create actually a Boolean variable. So we're going to call this Boolean variable isOn. And a good way to name a variable, a Boolean variable, is to use is in front of it. And it's kind of a convention that people use in order to indicate that it's a true or false value. So let's create another attribute of this printer. Let's create a string for the model number. And again, don't worry about this public declaration. We'll cover this a little bit more later. For now, this is just telling us that we're not hiding any of this data, that this data can be set by anyone using this class. So that's enough data for now. We've created our printer class, and really it's just that simple to create a class in Java. And what we've done is we've taken some things that are attributes of a printer. We said, what is the state of the printer? Is it on? And what is the model number of a printer? And you can see here, looking at this definition of a class, that this doesn't have the specifics of a particular printer. What we're going to do when we create an object is we're going to give values for this on or this model number, and that's going to allow us to create a specific printer. So now that we've created our class, we're going to want to be able to actually use our class to create an object. So let's go ahead and go into our main Hello World program where we have our main here, and let's try to create a new instance of this class. So in order to do that, we're just going to create a variable, just like we had done before with primitive types, but this time we're using the type printer. And one quick shortcut that you can do here is in Java, if you happen to know you have this class printer, in Eclipse you can hold Control Shift and O, and what that is going to do is auto import any kind of packages that are needed in order to access that type. And there's two ways I can do this. I can do printer, and we'll call this P equals new printer, and then I can hit Control Shift O, and it's going to automatically create this import statement. And what this does is this basically brings this package's name into our class so that we can use it. If something is declared in printer, right now we're in this greetings package, so we need to be in the printing package in order to use a printer. And this import statement is very specific, saying I want you to import this class that I'm going to use, this printing.printer class. We could have also just imported everything in the printing namespace, but typically in Java we just import what we need. The other way that I could do this is I could start typing printer. So I'll take out this import statement, and if I hold down Control and hit space, and I start typing some of the rest of the letters, I can see there's a printer here, and if I select this and hit enter, you can see it's automatically added this import statement for me. So let's create our printer. We'll create a variable called myPrinter, and then we need to assign this variable. And in Java, in order to create an instance of an object from a class, we use a special keyword called new and a special syntax of calling a method on the class that is called the constructor. So what we're going to do is we're going to do new printer, and then we're just going to do a begin parentheses and an end parentheses. And what this does is this calls what's called a default constructor on the printer. It's something we haven't created yet, and we're going to cover this a little bit more in detail later, but for now just know that this is the basic syntax for creating a new object out of a class that you've defined. Now, another thing that we're going to want to be able to do is to actually make this printer be specific, be different than any other printer. So in order to do that, we're going to need to actually set the data on this printer. And what we can do here now is we can call myPrinter and dot is just a way of calling a method or accessing data on an object. So in this case, we only have data. We don't have any methods that we've created. So we want to set the isOnState to false, and we can do myPrinter.modelNumber, and we'll set this to ABCD. So now we actually have a printer, and this printer is now specific. It has a state, it has a model number. Now in a real class, a real printer class, you'd probably have a lot more data than this. For this example, we're just going to set this data. We could create another printer called yourPrinter, just like this, and then we could set different data on this. We could say yourPrinter dot is on equals true, and yourPrinter dot model number equals FGH. So now we have two different kinds of printers that have different data. So you can see the difference between a class and an object. These are two different objects, but they're defined in terms of this class. So let's prove that we have some data on our printer. Let's go ahead and print out what the model number is for my printer. In order to do that, I'm going to call system.out.println, and then I'm going to pass myPrinter.modelNumber. And again, we're using this dot syntax to get the value out of this variable. So let's go ahead and run this and see what happens. You can see that it's printed ABCD, which is the model number. And right below this, if I printed from your printer the model number, we would see that it's indeed different. And that one is FGH. So you can see here that we're able to create an object. It's really simple. We just have to use this syntax. We declare the variable to store the object, give it a name, and then we call this new in order to call the constructor on our class. So our class really isn't very useful since it's just holding data. It doesn't have any kind of way for us to manipulate that data. It doesn't do anything besides hold data. Really, a class needs to have methods as well. So let's look at how we can create a method and what a method really is in Java. So we had talked a little bit about methods before, and I'm looking at our printer class here. What we had said about methods before is that a method is a way to act on some data or to manipulate that data that's related to the class or related to that data that belongs to that class. So let's do something useful. Let's create a way to print. So a printer should be able to print something, and in this case we're not going to try and print something to paper. We're just going to print out the model number in this example. A lot of printers are able to print out a spec sheet or configuration page that says what their model number is. Let's create that kind of capability. So I'm going to use this syntax. Again, don't worry about this access modifier yet. We'll cover this a little bit more later, but this just tells you that anyone can call this. And we're going to call our method print, and we're going to specify the return type for this method, which is void. This keyword void basically tells us that when we call this method, there's not going to be any result from this method. It's not going to return back a value. When you create a method, you can also return back a value and then use that value. So a method can be used to perform a calculation. In this case, we're going to create the simple case first, which is basically to just do something. So let's have our method print the model number. So let's call system.out.println, and then let's have it print the model number. Now you'll notice also that I don't have to say printer or my printer or anything model number. Instead, I'm using this class level variable. So from within your class, a method in your class can use any data in that class. So it can just reference model number, and it's going to use whatever we set the model number to. Now you'll notice a problem here, which is what happens if we don't set the model number, and that we're going to cover when we get into constructor, but you're going to see why we're going to need to use a constructor in order to make sure that our class, our object, is in a good state when it gets created. So let's go ahead and try this out and see how this print method would work. So we can go in here, and I'm going to eliminate these lines that we're doing the print, and now we're going to call myprinter.print. Now what's going to happen is we're going to call this method on our object, this print method, and this print method is going to actually do the print line. So let's go ahead and run this and see what happens. You can see ABCD is printed out. So that's how you can create a method, and a method is definitely going to be useful when creating a class because it allows you to do something with your class. So let's look at some other things that we can do with methods. Well, we created a method that basically just did an action. It didn't take any input, it didn't put any output. We can do two things with a method. We can give input and we can give output as well. So let's try creating a method that is able to take some input. And in this case, we're also going to use a concept called overloading, which is to have the same method name but to have a different way of calling it. So we're going to create a special kind of variable here called a parameter, and we'll make this a string. We'll call this text. And what we're going to do here is we're going to pass to this method a value that is going to be used in this method. So I'll take this system.out.println, and now we're actually going to use this. I'm going to use this text value. So you can see what's going to happen here. If you think about this, we're going to call this method now. We're going to provide a value here, a variable of the string type called text. And then whatever we had passed in here, that's what's going to get printed out. So let's see how we could use this in action. Instead of calling myprinter.print and not passing anything, let's use the version of this method, the overloaded version, where we take a string. So in this case, I'm going to print hello printer. Now what's going to happen here is that when this print method is called, it's going to take this string that we've passed in, it's going to be set to this variable called text, and then this text is going to be passed into this printing method in order to print it out to the screen. So let's run this and see what happens. You can see the words hello printer were printed out. So now we've actually done something useful. We've created a method on our printer that allows us to put in any text we want and then spit that back out. Now let's look at one other thing that we can do with methods. Let's create a method that will return us the model number. Now this isn't very useful because we know we can just grab the model number just by calling dot model number and getting that data out. But when we actually try to hide the data, which is a best practice of creating a class, later on we're not going to have access to this model number. We're going to need some kind of method in order to do that. So let's go ahead and create that method. So I'm going to do the same thing here, except instead of using void here, we're going to specify a return type. This is the type of data that this method needs to return, which in this case will be a string. And we're going to call this method getModelNumber. And in Java, this kind of method is known as a getter. This is a special kind of method that allows you to get some data from the class. We also have another special kind of method in Java called a setter, which allows you to set data on a class. So let's look at how we would implement this method. What we can do here is we use a keyword called return, and this is going to return whatever comes after this return keyword. In this case, we want to return the model number. So now you can see that what our method is going to do is when this is called, it's going to just return a string that is the model number. Now we can actually assign whatever comes back from here to a variable. Let me show you how we can do this. So I'll get rid of this line here, and we'll create a new variable of type string called the model number, and then we'll call myPrinter.getModelNumber. Now you can see what we're going to do here is we're going to get the result of this method call. When we call myPrinter.getModelNumber, it's going to return us a string. We're going to immediately assign this string to this variable. So now I could actually print this out from inside of our main by doing system.out.println and then printing the model number. Let's run this, and you can see it's printed the model number. So just to recap what we've covered here, we basically saw how we can create methods inside of a class, and these methods operate on the data that's inside of the class. We created a method that didn't return anything, but it did something. It actually printed to the screen what the model number of the class was. We saw how we could create a method that took a parameter, and if we wanted to specify multiple parameters, we could do that as well. And we can use each one of these parameters. When we call a method, we simply pass in what we want to use as a parameter. So in this case, we had passed in the value of hello printer, and it printed out that value. Then we also saw how we could create a method that could return a value, and we use this return keyword to return a value back, and we returned the data that was part of our class or part of our object. So now let's talk about another important concept, important part of creating a class. This is the initialization of that class, or setting up some initial data, and what we call that is a constructor. In Java, we use a constructor to set up our class or to construct our object from our class. Now, we saw here that when we called new printer here, we used what was called a default constructor. We didn't implement a constructor. We didn't create a special kind of method here in order to do the construction. By default, Java will automatically give this to you, and it will just create an instance of your class, an object from your class, and it won't do anything in addition to that. But we can create a special kind of method called a constructor, and the way that we do this is we do public, and then we say the name of our class, so printer, and then this method can take some parameters. So let's create two parameters, one for on, and then one for the model number. And we'll create this as isOn and the model number as model number. And what you'll notice here is this is our scoping problem is going to come into play here, and we're going to have to use another special keyword in order to refer to the class level variable instead of this method level variable in order to do an assignment here. And what we're going to do here is we're going to take in some values, and those values that we take in, we're going to use them to set up our class. So we're going to take in an isOn value, and then we're going to use this operator, which allows us, even though this name is the same to specify that we're talking about the class level variable. So we can set this is on equal to is on, and we can set this dot model number equal to model number. Now we could have also just initialized this to a default value. We could have not specified this is on and just said that if you don't specify it, we're going to make is on be equal to false. But in this case, let's see how we can use this constructor to automatically create a printer that has the values that we want set on it. And we'll leave these other methods in place so that we can examine what the value is going to be. In fact, let's modify our print method so that it will also tell us if the printer, what state it is, if it's on or not. So let's go back into our hello world. And now you can see that we don't have a default constructor anymore because we've created an actual constructor. And so now we have to use the constructor we created. We have to actually pass in some parameters into our constructor. So I'm actually going to get rid of all of this code, and we're going to start over here, and we're going to just create a new printer. So let's create a printer called myPrinter, and we'll do new printer, and I'm hitting Control and space to see this list of what the parameters are. And you can see the first one is a Boolean, whether or not it's on. Let's say true. And then for the model number, let's make it my printer. Now you can see what we've done here is we've initialized this printer object, and we can prove this by calling myPrinter.print. And now you'll see that it is true and the model number is my printer. So let's run this, and you can see is on is set to true and my printer is a model number. We could create another printer, and it could have different values. So for your printer, we'll set this equal to false, and we'll call the model number your printer. Then let's print this one out, and let's run this. And you can see it's print out the values of the second printer. So a constructor is basically something that you're going to use to initialize your class or initialize the object that you create from your class. So we've been ignoring one topic as we've been working through our classes, which is these public declarations that are in front of all of our classes and data. We're just going to cover 3 of the possible access modifiers right now in Java, and we're just going to cover these in regards to methods and to the data members. So what you're seeing here now is basically a way that we can specify how this method or this data can be accessed. And public is a way that we can specify that anyone can access this. You don't have to be part of this class. You don't have to have any kind of special restrictions or special privileges in order to access this data. Now I can demonstrate what will happen if we take away this public, if we change this, and you can see what will happen here with this model number. So let's take a quick look at what the difference between public is and the other access modifier I'm going to show you called private. So we'll leave the model number as public, and I'll go into this hello world program, and we have our printer here that we created. We'll delete this other printer, and notice that we can change the model number. I can access this. I can call my printer dot, and you can see that model number is visible here, and we can set this to new value. Now if I run this, you can see we've actually changed the model number. This is bad because we are able to reach inside of here and change this class's data. Really, the class itself should be responsible for its own data. Other people shouldn't be able to change its data. So we can change this so that that can't happen by changing this from public to private. Now you'll see that this code won't compile because this model number is not visible. You can't actually see model number. If I hit dot here, you can see the is on is still public, but model number has disappeared. Now this is the reason why we had created this method called getModelNumber. What we had done here is given someone a way to get the model number. without being able to modify the model number. And that's really the value of using an access modifier. So the basic access modifiers that you have are public, private, and protected. And we're not really going to cover protected right now. Protected is going to be used when we talk about inheritance, and it's a way to make it so that when you have another class that inherits from your class, it is able to access that data or that method. That concept isn't going to make much sense to us yet until we start talking about inheritance. Private simply makes it so that the only thing that can access this data or this method is the class itself. So you can only access it from inside the class. In this instance, we had seen that the model number was not accessible from outside. It gave us a compile error when we had set this to private. But you can see here that we're accessing the model number and changing it inside of our class. We don't get an error here. And that's because private allows us to have the visibility only from within our own class. There's also another type of access modifier, which is called a default access modifier, and that's when we don't specify one. And that has a couple of special attributes, but we're not really going to get into that right now because we're going to try to keep this as basic as possible. And mostly what you're going to be using is public, private, and protected. And really, the general rule of thumb when creating data is that you want to make all your data private, and you only want to expose what you need to expose externally. We could also make methods private, and that would make it so that we can only call those methods from within our class. So let's take a look at a quick example of how we could do that. So let's take this print method and let's change it so that it is private. Now you can see that we can't actually call this print method specifying a string to print from outside our class. If I went my printer.print, you see there's only one method showing up. But I could call this print method that takes a string inside of our class. So for example, in our print method here, we could call the other print method and pass in a string. Now what will happen is it will print out the isOn value, the model number, and then it'll print I can call this. So let's go ahead and run that and see what happens. You can see here that when we've called print, it's called I can call this. So really an access modifier is a way to lock down your data or to expose your data in your classes. So let's go over what we covered in this module. Well, the first thing that we did is we defined what a class is. I showed you from a very high level what a class is, and we kind of drilled down deeper, understanding that a class is really a custom type that we're able to make, and that really a class is a grouping of methods and data. We saw that if a class is a blueprint, then an object would be a house, or if a class is a cookie cutter, then an object would be that cookie. Then we went through and we talked about members. We talked about how to make up a class, and that a class consists of data and methods that operate on that data. So we saw how members are really the thing that builds up a class. Then we went through some examples, and I showed you how we could create a class. We created a printer class, and we made some data for that printer class, and we saw how we could create different instances of that printer class and then use those objects and manipulate those objects in our code. Then we went through and we needed to do something useful with our printer class, so we created some methods to be able to print, and we created a method to be able to get our model number from our object. I showed you some of the ways that you could use methods, and we played around with some ways of using methods on our printer class. Then we went over an important point of how to initialize our object. I showed you how you could create a constructor that would allow you to pass in some data that you could use to create your class. And then finally, we went over some of the access modifiers in Java. We didn't cover all of the access modifiers and all of their uses, but we basically went over public and private and saw how we could use access modifiers to hide certain data in our classes and to expose other data and methods. Well, that's it for this module on classes. Hopefully you've learned a little bit about what a class is in Java, and there's a lot more to this subject, but I just wanted to give a basic introduction so that we can build from this and get into some of the more complicated aspects of Java. Hi, this is John Sanmez from Pluralsight, and in this module we're going to be covering control statements in Java. And really up to this point, we haven't done anything particularly interesting in Java. We've learned about Java itself, we've learned about variables and how to declare them, and we've learned about classes in Java, but we haven't actually been able to solve any problems or to do any real logic. And the reason why we haven't been able to do that is because we haven't gotten to control statements or conditional statements. Control statements allow us to actually branch our code and to change the flow of the execution of our code. This allows us to actually solve problems and to do some interesting things in Java. So let's go over what we're going to cover in this module. Well, the first thing that we're going to do is we're going to talk about control statements in general. There's basically three types of control statements, and I'm going to introduce those three types to you so you can understand from a high level what kinds of control statements can exist. Then we're going to go down and we're going to cover each of the particular types of control statements that exist in Java. First, we'll look at the if and else statement, which is a basic way to branch your code based on a Boolean condition. Then we'll get into the switch statement, which is a way to do almost the same thing as an if and else, but is a lot cleaner when you have a series of conditions that you want to check and do something based on that condition. Then we'll look at our first loop, which is the for loop, which is a loop that allows us to increment a counter while we're looping through some section in our code. And then we'll look at the for each loop, which is another special kind of loop, which makes it very easy for us to do a loop and to loop through things in a container or in some kind of collection. Then we'll look at the while loop, which is just a very simple and basic loop that allows us to loop until some condition is met. And then finally, we'll look at the break and continue statements, which are used to get us out of a loop early, either by breaking out of the loop entirely or continuing to the next iteration of that loop. Control statements are a very important part of any programming language. Without control statements, there isn't much that we'd be able to actually do in our programs. Control statements allow us to be able to branch to different parts of the code, to be able to loop through the code, and to be able to jump to different areas of the code. Without these kinds of statements, our code would basically just run from start to finish without ever returning back up or looping or choosing a different path. So the basic idea behind a control statement is that it allows us to control the flow or the execution of our code. And control statements can basically be divided into three main types, and we're going to cover some of each one of these types in the rest of this module. The first type that we're going to cover is conditional statements. And conditional statements can be thought of as statements that allow the code to branch or to choose a different path. We're going to cover two types of conditional statements. One is the if and else statement, and the other is the switch. And both of these statements we'll see will allow us to evaluate some kind of condition and then choose a code path to take based on the value of that condition. The next type of control statement that we're going to look at is an iterative control statement. An iterative control statement is basically just a loop. And we're going to look at several different kinds of loops in Java and see how we can construct the loops and how we can both enter and exit the loops. The final kind of control statement is a jumping statement, and we've already covered one of these so far. The return statement, when we looked at methods, is an example of a jumping statement, and that's because it jumps from one location of the code to another location of the code. There's two others that we're going to cover here, and they're both related to loops, which is the continue and the break statement. And we're going to use these statements in order to exit a loop early or to go to the next iteration of a loop early. The first control statement that we're going to look at in Java is the if and else statement. This is one of the most basic statements that we can use in order to branch our code in some way or to execute some conditional logic. So I've got our printer class open here from our Hello World project, and we are going to modify this so that we can do something useful based on the state. If you remember, we had created our printer, and we even created a constructor so that we could create a new printer set whether or not it's on or off and set its model number in the constructor. And then we, of course, printed out the value of our printer. And if I run this right now, we can see that it prints out true because it's on, and then the model number. But let's try and do something more useful than that. Instead, let's make it so that this print statement will tell us the model number and then whether or not the printer is on. So right now, we can't really do that very well without some kind of a conditional statement. What we really want to do is we want to say if the printer is on, then print the model number and is on, so that we can say this model number is on. We don't have a way to do that without using a kind of statement that we're going to see now, which is the if statement. So let's go ahead and comment out these print line statements, and let's change this so that we're now going to make it so that if the printer is on, then we want to say the model number and then that the printer's on. So the way that we do that is we just use if, and then what goes in these parentheses has to evaluate to true or false. So it has to be Boolean. We could just put the word true here, and this would evaluate to true. We could put false there, it would evaluate to false. Or we can put any kind of statement that's going to result in a true or false there, or a variable that's a Boolean type. In this case, what we're going to check here is this is on variable. So we can check if is on, and then we can do something here. Now, we can execute one statement after this check, the if condition is true, or we can use a block here and execute multiple statements, as many as we want. In this case, we're just going to need one statement, but I'm going to go ahead and use a block here. A lot of people like to use blocks and if statements because if you add more statements to them, you don't accidentally create a new statement on another line that doesn't get executed as part of this if. So in this case, let's check if the printer's on. Let's do system.out.println, and then we'll print the model number plus is on. So now we're going to check to see if the printer's on when this is called, and if it is, then we're actually going to print something out. And if it's not on, we're not actually going to print anything out at all. So let's go ahead and test this out and see how this works. So I'll go to our hello world, and we'll run this. And you can see it's printed out the model number, which is my printer, is on. And if we created a printer that was not on, and then we ran this, you can see there's no output. It didn't print anything. So the basic syntax of an if statement is very simple. We just say if, we check our condition, and then we put what we want to do if the condition is met, either in a block following it or the very next statement. We could have also written this like this without the block statement, and that would have worked as well. Now, one thing that we might want to be able to do is to have another piece of code execute if the printer is not on, if this condition evaluates to false. And we can use an else statement to achieve that. So in this case, all we have to do is you already have to have an if statement. You can put your code to execute if the if statement is true in a block, if you want or not. And then you need to put an else statement, and you can put the code to execute in a block or not there as well. Now what will happen is, if this condition evaluates to true, what is in the if statement, or the if block, will execute, and if it evaluates to false, what's in the else will execute. So we can take this same system out print line, and then in this case, let's print is off. And I just wanted to say something here about these strings here. Generally, you don't want to concatenate strings by using this plus symbol in Java. There's some better ways to do this. We'll probably cover this a little bit later on, but just so if you're looking at this and saying, oh, can't you format that string? If you know what I'm talking about when I talk about a string formatter, then go ahead and use a string formatter in Java. But if you don't, if you're just starting out, I just want to show you the if and else statement, and I want to keep things as simple as possible. So that's why I'm just using the plus, because I think the plus is a lot easier for people to understand when they're first learning a programming language. So now let's see what this code will do when the printer is off and when the printer's on. So I'll save this file. We'll go ahead and we'll run. And right now the printer is off, so we get my printer is off. And if we set this to true, then you should see that it's now saying that it's on. So that's it. That's the if and else statement, a simple way to branch your code. The next kind of control statement that we're going to look at is a switch statement. And a switch statement is a statement that allows us to evaluate the value of some variable or some statement, some expression, and based on that value, do different things for different values. So a good example of a way that we can test this is we can have our print statement print a certain number of copies, and based on that number of copies we're going to print out the model number and then is on or off that many times. So let's go ahead and modify our print statement so that it'll take in a number of copies. So we'll put int copies here, and this will be the number of copies, and then we can use a switch statement by calling switch, and then what we want to switch on. We want to switch on the number of copies, and then what we'll do now is inside of our block here, we're going to provide cases for the different cases that could exist. So case of 0, we can do something. And for each one of these case statements, we need to provide a way to get out of this, either to return or break, so that we don't fall through. Because a switch statement, what will happen is, if we have a case 0 and a case 1 here, if our number of copies that comes in is 0, it's going to execute the code that we put after this case 0, and then it's going to go right on to case 1. It basically falls through in Java. So this can be useful if we want to utilize this in a switch statement, but if not, we can use this break statement, which we'll cover a little bit more in detail later when we get into loops. But for now, we can just know that you'll need to put a break statement after each case if you don't want it to fall through. So I've got a case 0 and a case 1 here. And what I'm going to do here is I'm going to put after this case what I want to happen in the code. So we're going to do something that's a little inefficient here for now, and then we're going to make it more efficient when we get into loops. What I'm going to do here is I'm going to put our code that prints here, but I'm going to put this only for the case of 1. So in the case of 1, then we'll print this statement once, either the on or the off. In the case of 0, we're not going to do anything. Let's go ahead and add another case here. I'm going to add a case of 2. If the copies amount is 2, then we're going to print this twice. And if it's off, we'll print this twice. And again, this is very inefficient what we're doing here, but I just want to demonstrate to you how the case works and then show you how a loop will help to make this code a lot cleaner later on. Right now we're programming without a loop, and that's why this is going to be a little bit messy here. The other thing that you can with a switch statement is you can have a default case. So if it doesn't match 0 or 1 or 2, then we can choose to use the keyword default, and this is a special case. This default case is going to get hit if it doesn't match any of the cases that are here. So if our copies is passed in as a 3, it's not going to hit 0, it's not going to hit 1, it's not going to hit 2, it's going to hit the default here. In this case, we're going to print out number of copies is not supported. So if anyone picks a number greater than 2, we're just not going to be able to print that out. We're just going to say that it's not supported. So let's go ahead and run this and see what happens. We'll have to go in and we'll have to modify our call to print because we've required a parameter now. If you remember, we've added this copies parameter. So let's make a copies of 0 and see what happens. I'll run this and you can see nothing has happened because what has occurred here is we passed in a 0 here. We switched on copies, which was 0. And because it was 0, it went to this case 0 and it did nothing. It just broke out of the switch statement. So now let's try print 1 for 1 copy. We get my printer is on because the printer is set to on. And what we can see has happened here is it switched on copies. Copies was 1. We have a case 1. It executed everything here until the break. Then it broke out. Let's go ahead and try print 2. And you can see it's printed my printer is on twice. And that's because when we went into our switch, the copies was 2. It hit this case. It hit this is on statement, and then it simply printed out twice. And again, this is not very efficient because we're repeating a lot of code. We have a lot of code duplication here, and that's because we don't have the ability to use a loop because we haven't learned about that yet. But once we get to a loop, we're going to be able to clean that up. Now let's give a number that's greater than 2. Let's put 50 here and see what happens. You can see number of copies is not supported because it's hit this default case. And let's see what would happen if we took away one of these break statements. Let's say that you forgot on case 2 to put a break statement here. So let's delete this. Now we'll go back and we'll make it so that we try to print 2 copies. And we'll run this. And you can see it actually hit the statement for 2, but then it went right on and hit the default statement. It fell through. So it's very important to remember to put a break statement or some kind of return, something to stop it. Otherwise, it'll just fall all the way through. And sometimes the behavior you want, for example, if you wanted to do the same thing for, let's say, 1 and 5, we could actually do case 1, case 5 here, and you can see either 1 or 5 is going to execute this code right here. So I'll go ahead and switch this to a 5 now, and you can see that it still did what 1 had done before. So a switch statement basically lets you switch based on the value of some value, and if you're using Java 7, you can actually switch on a string. So you could put a string here and not just a number, but if you're using an earlier version of Java, it'll have to be an integer to switch on. And you can see here that we could make our numbers go up to any number up here, and we can provide cases for any number of values that we wanted to. And we always have this capability of creating this default case. And we don't need a break here on the default case because there's nothing for it to fall through to. The next statement that we're going to look at in Java is the for statement. And this is not the simplest of loops, but it's perhaps one of the most common loops in Java. A for statement is a statement that allows you to loop through a series of statements or execute some code a number of times, and in that process it allows you to keep track of a counter or to do some action on every loop. So let me show you a simple example of a for statement, and what we're going to do is we're going to simplify this code. We're going to do a little bit of what's called refactoring here, and this code right now is a mess because it's really duplicating a lot of stuff here. We see that we have the same line kind of printed out in these different places, and when we want a case for printing 1 copy, we do one of these statements, and when we have the case for 2, we just repeat it, and that's really inefficient, and it's really copying a lot of code. And so when this changes, if we wanted to make a case 3, we'd have to have 3 of these print lines, and that's really just not a good way to go. But with a loop, we can simplify this. So I'm going to create a loop up here. We'll go ahead and delete these statements. Now I'm going to show you how we can use a for loop. So the syntax of a for loop is you use for here, and then you have some parentheses. And there's 3 things that go into the parentheses, and they are separated by 2 semicolons here. So I'm going to put these semicolons in place, and I'm just going to put what each one of these is. So this first section here is going to be an initializer. The second section here is going to be the condition, and the third one is going to be an increment. So the idea here with a for loop is you need to initialize some variables or some kind of count. You check it. Every loop, it's going to check this condition and see if this condition still evaluates to true. If it doesn't, it's going to quit looping. And then you want to be able to increment. You want to be able to do something that changes the condition so that it will eventually end. So let's go ahead and see an example of this. So I'm going to use integer I here. I can declare a variable right inside this for loop. So I've declared a variable called I, and I is commonly used for a counter. You could use a name like count, and that's a little bit more descriptive, but for this example I'm going to use I to save a little bit of space here and make it easier to read. So here I've declared my variable I, I've set its count to 0, and we're going to loop until I is less than the number of copies. And then I have another semicolon here, and then every time we loop, we're going to use this I++. And if you remember, this I++ is the same thing as saying I equals I plus 1. What we're going to do is we're going to increment I every time. Now the same thing as with an if statement, we could just use one single line here, or we can use a block. Commonly in a loop, you're going to use a block, and everything that's in this block is going to get executed every iteration of the loop, or every time this loop goes around. So right now, if we just looked at this structure here of this for loop that we have, we're going to start at 0. It's going to check and see, is I, which is start at 0, less than the number of copies? If it is, then it's going to increment I, and then it's going to go on and do what's in this loop. So, for example, if we put in a copies of 2, I is going to start at 0. I is going to be less than 2. 0 is less than 2. So then I is going to become 1. Then it's going to do whatever in here. And now we have an I equal to 1. It's not going to re-execute this initialization statement. Now it's just going to check this value. 1 is less than 2. So we're going to get I++, which is going to make it 2. Then we're going to execute what's in this loop. And now, is 2 less than 2? It's not, so we're done. So it's going to execute that loop 2 times. So let's actually change our code to make use of this, because what we're doing in our print method here is we're trying to print the number of copies. We want to print this statement, is on or is off, however many times that's passed in here. And we only supported 1 or 2, or the default. For the default, we said number of copies is not supported because we couldn't really support 3, 4, 5, 6, 7. It would have been a lot of coding to write all that code. And we could never have supported 1,000. It would have been way too much typing in order to support that much. But using a loop, we can support pretty much any number of copies. So what we'll do here is we'll take this whole if statement and we'll just move it inside this loop. So now what we're going to do is, however many copies there are, is how many times we're going to go through this loop, and each time we're going to print either the model number and then either on or off. So we'll take out this old switch code, and you can see how much code that we've been able to eliminate just by getting rid of that switch statement and replacing it with a loop. This loop is going to be a lot more efficient. So let's go ahead and run this and see what happens. And we'll go ahead and leave this 5. We'll print 5 times. You can see here it's printed 5 times. If I put a 1 in, it's only going to print once. If I put in 0, it won't print any times. It completely skipped it. And I could even put in 10 here, and it will work as well. You can see there's 10. So what's happened here? What happened when we put in 10? Well, we had 10 get passed in. It was set to copies, and we looped from 0 to 10. And this is one of those things that always confused me when I was first starting out programming, is how to initialize the for loop and how to know how many copies I want to do. It starts at 0, or do I start at 1? The best thing to do is just to kind of memorize this kind of convention here. So if you start at 0 and you always make your variable less than whatever the max is, you're going to get that number of iterations. So for example, when 10 comes in here, because we start at 0 and we're looping till I is less than 10, it's going to happen 10 times. You could also start at 1 and then say less than or equal to. But I find that a little bit more confusing. I think it's a lot easier to just remember to do it this way for a for loop. Now, for loops can be more complicated than this. We're not going to get into all the details here, but you could have multiple statements here. You could initialize different variables. You could have a complex condition here. The basic idea here is that you have this initialization that happens once when the loop is first entered. You have this conditional that is checked every time, and if it ever evaluates the false, the loop is done. And then you have this other statement that executes on every iteration of the loop that can access whatever variables you've declared here. There's one more refactoring I'd like to do here just to make this a little bit cleaner. You see that we are actually checking this if statement on every iteration of the loop. What we can do is we can pull this out and we can just check once to get our text here and use a variable and print out the value of the variable. So let's try that. Let's create a string, and we'll call this text to print, and we'll set this equal to model number plus, and then we need to have either is on or is off. So let's stop this thought for a second, and let's create another string, and let's put the is on or is off in this string. We'll call this string on status, and we'll set this equal to, let's set this equal to an empty string at first, and then we'll say if is on status equals is on, else on status equals is off. Now we can make our text to print be equal to our model number plus our on status. And then inside of our loop, we can eliminate this whole if block, and we can just say system.out.println, and we're just going to print the text to print. Now we've simplified things a lot better, and we've made it a little bit cleaner to read this code, and we're not executing this if condition every time we go around the loop. We're only executing this once to build our string, and then we're printing it out however many times. So the next kind of loop that we're going to look at in Java is the for each loop. And this is one of my favorite looping constructs because I think it's a very elegant loop and it's very easy to do, and it makes a lot of tasks that would have been much harder, much easier to do. So in order to create this loop, I'm going to create an example here, and we're going to create a print statement that will allow us to print the different colors, red, green, and blue. And we could fill this with more than those colors, but let's just make an example where we have red, green, and blue, and we want to print those colors. So I'm going to create a method here called print colors, and it's not going to take any parameters. And the idea here is that we're going to create an array of colors as strings, and we want to print each one of these out. So I'm going to create a string array, and I'm going to use a special syntax here in order to create this string array. What I'm going to do is we're going to declare this string array just like we did before, and we're going to call this colors, and then we're going to do new string, and then we're not going to specify the length of the string like we had done with an array. We could have put 10 for 10 strings. Instead, we're going to let the compiler figure this out. Instead, we're going to use some brackets here, and then we're going to put our strings followed by commas, and the compiler will figure out how long to make the array. So I'm going to do red, comma, blue, comma, green, then a semicolon at the end here. So now we have an array of colors. Now, a for each loop will let us basically iterate through this array, or really anything that is iterable in Java. And iterable is just a fancy way of saying that you can loop through it. There's a lot of things that you can loop through in Java. Anything that it would make sense to be able to loop through, like a list. In this case, we're going to use an array. And when we get into collections later, you'll see that we can loop through most collections. But we can use this for each loop in order to loop through this array. And the syntax for the for each, it looks just like a for. It's just the keyword for. It's called for each, but it's actually just for. And what you do is you declare the variable that's going to hold the temporary value of the element, the current element in the array, because it's going to go through each one of these. So we'll create a string, and we'll call this current color. And then use a colon here, and when you use the colon, you can think in your head in. So we would say current color in colors. And this is going to loop through every color stored in current color in this colors collection. So for each current color in colors, do this. And what we can do here is we can just do system.out.println, and then we'll print whatever the current color is. So thinking about how this is going to work, it's going to look at this colors array. It's going to loop through until it's hit every single one of these, and it's going to store it in the current color each pass through. On the first pass through, it's going to have red stored in here. Then it's going to print out red. On the second pass through, it's going to have blue stored in here. It's going to print out blue. On the third pass through, it's going to have green, and it's going to print out green. So let's take a look at how this will work. So let's, instead of calling print, let's call print colors, and then let's run this and see what happens. You can see it's printed red, blue, green. So it's real simple. This is a very elegant loop. I really like this loop because you don't have to, like we had to do in this for loop, we had to figure out where to start and where to end. Instead, the for each loop is able to do that for you. All you have to do is choose a variable that you're going to store the current item in, and then use this colon and then your list or whatever collection, whatever iterable thing that you have. In this case, we have this array of colors. The other nice thing about this is that we can easily expand this. If I added yellow, comma, orange here, it's automatically going to work, and we don't have to do anything else. So I'll just run this, and you can see now it's added those colors. So for each loop is a really useful loop, and you just have to remember the syntax. It's the same as the for loop, except you're going to use this colon here, and you're going to declare your variable to store for each item, and then you're going to give the actual array at the end here. So the last kind of loop that we're going to look at is called a while loop. And there's a variation of this called a do while loop, but we're not really going to look at this because mostly you're going to use while loops. In fact, you really never have to use a do while loop. There are certain conditions where it might be more convenient, but a while loop is really the one that I think you're going to use a lot more often. So a while loop is a very simple loop. It's actually more simple than a for loop, but it's not quite as powerful because you have to do a little bit more because you have to handle the increment or decrement yourself. So we could actually rewrite this print method to use a while loop instead of a for loop. So if you remember, when we created our for loop here, we looped basically starting at 0, and then every time we incremented our count until it was greater than copies or equal to copies. As long as it was less than copies, we continued to loop, not less copy that number of times. With a while loop, we can write this exact same code, except a while loop simply has a while statement, and then what's in parentheses is a Boolean condition, either true or false. And if it's true, it's going to continue to loop, and if it's false, it will end the loop. So we could actually do while true here, and this would loop forever. It would create an infinite program. It would never end, because there's no way to get out of this loop. But what we can do here instead is we can say while copies is less than or is greater than 0, then let's print this out, and then we need to modify copies. So we're going to do copies minus minus. So what's going to happen here now is as long as copies is greater than 0, as long as this evaluates to true, then it's going to continue to loop, and it'll print out our text. And then it will also subtract 1 from our copies. So if we put the copies of 5 in here, it would come in 5 is greater than 0, it'd print the text, it would set copies to 4, 4 is greater than 0, so on and so on until our copies hit 0, 0 isn't greater than 0, so then it would exit our loop. So let's go ahead and try this out and see how this would work. We'll change this to print, and we'll print, say, 4 copies. If I run this, you can see we've printed 4 times. And if I change this to 1, you can see it's just printed once. So a while loop, again, a very simple loop, but you do have to be careful that you don't get into an infinite loop. And you just have to make sure that whatever conditional that you create here, that within your loop, you're changing that conditional so that it'll eventually be met. You're changing the variable that make up that conditional. So the last 2 control statements that we're going to look at here are the break and continue statements. And these statements are really used in a loop or in a switch statement. You saw when we had this print method and we had used the switch statement, we're using break, so we kind of already understand a little bit how break works. What it does is it breaks us out of whatever we're in. Usually that's a loop, or it could be a switch statement. I'm going to show you how break works first in this print colors method. So anytime that you're in a loop, if you decide that you want to exit that loop, you can always call break, and then it'll immediately exit the loop as if the end condition had been met. So we can do this in a for loop, a while loop, a for each loop, any one of those loops. In this case, let's do something here. Let's break out of the loop when we hit green. And the way we can do that is we can check to see if the current color is equal to green. We're going to skip it. And so what's going to happen is we'll get red, we'll get blue printed out, but we're going to skip green and we're going to be done. So the way that we're going to implement this is we're going to use an if here. We're going to check if, we'll say if, and we're going to use a special syntax here to compare strings. We don't want to say equal equal when we're using strings because strings are objects, and with the equal equal operator, if you compare 2 objects, it's going to check to see if they're the exact same object, not if they're basically equivalent. And this is kind of a little bit of a complex topic with the equals, but you just have to know that when you're comparing objects, if you want to compare the values, especially this is a rule you have to follow with strings, and this is different than C#. In Java, if you're familiar with C#, this is going to seem a little bit weird to you. But in Java, you want to do a string comparison like this. you'll do your string dot equals and then your other string. So we're going to say if green equals the current color, then we're going to break. And this will break us out of the loop. And this does look a little bit weird, but all we're doing here is comparing two strings. We could have written this as equal equal, but that could cause a problem if these strings aren't the exact same string, which a lot of times they're not going to be because they're different memory locations. So let's go ahead and run this and see what happens here. I'll change this to print colors, and we'll run this, and you can see it's just printed red and blue. It didn't go through our whole list because once it got to green, this if statement evaluated to true and it hit the break and it broke out of the loop. Now let's say that we didn't want to break out of the loop. We just wanted to skip green because we don't ever want to print green. We just want to print all the other colors. If instead of a break statement I use a continue statement here, it's not going to break completely out of the loop. What it's going to do is when it hits this continue statement, it's going to be like it hit the end, this end bracket of the loop. It's going to go back to the beginning of the loop. And so it'll print red, it'll print blue. When we get to green, this if statement is going to evaluate to true. It's going to hit the continue, which is going to cause it to skip the print line, and it's going to go back to the top of the loop, and it'll then hit yellow, and then it'll hit orange. So let's go ahead and run this and see how that works. You can see here red, blue, yellow, orange. So basically a break statement is going to break out of a loop, and it'll work for a for loop, a while loop, a for each loop. And a continue statement is going to end that iteration of the loop and go on to the next iteration of the loop, just like you would hit the end bracket of the loop. So let's go over what we covered in this module. Well, the first thing that we did is we talked about control statements. We talked about the basic idea of a control statement being some way to interrupt the flow or change the flow of your programs, and that without control statements, our programs would just flow from top to bottom without ever choosing a path to go down or doing any kind of looping or jumping around. Then we went through and we looked at each one of the control statements that exist in Java. First, we looked at the if-else statement. We saw how to create an if statement that would check a condition, whether or not it's true or false, and then execute some code. And we could use the else statement to execute another branch of code if the statement was false. Then we looked at a switch statement, and we saw how we could use a switch statement to switch on a particular value and then have a bunch of different cases and execute different code based on each case. Next, we looked at the for statement. We saw that this is one of the simple types of loops that we can create in Java, and we saw how we could use a counter in a for statement to do things like iterate through a list or to count and exit the loop after we've reached a certain count. Then we looked at a for each statement, which is a specialized kind of for statement that makes it real easy to iterate through a collection or list of items. Then we took a look at the while loop, which is perhaps the simplest of loops. It will continue to loop until the condition that we're looping on is false. Then finally, we took a look at the break and continue statements. We saw how we could use a break inside a loop to break out of a loop early based on some condition, or we could use the continue statement to go to the next iteration of the loop. So that covers all of the basic control statements that exist in Java. And with these control statements, now you'll be able to create a much more complicated Java program and actually be able to solve some algorithms. With the knowledge that you've covered so far in the modules up to this point, you should now have the ability to actually write a Java program that would do something useful. Now in the upcoming modules, we're going to get some more tools that are going to allow you to enhance your skills in developing a Java program and to make your programs more efficient. But in general, you have what you need now to understand the basics of Java programming. Hi, this is John Sanmez from Pluralsight, and in this module we're going to be talking about inheritance and composition in Java. So let's go over what we're going to cover in this module. We're going to cover a lot of ground here, and this is a fairly complex topic, but we're going to try and make this as simple as possible and really try to get the most benefit that we can out of this so that we can design our programs in Java and our classes to be very easy to use and easy to reuse. So the first thing that we're going to talk about is an important distinction between inheritance and composition, which is the ISA and HASA relationship. And we're going to talk about how these two types of relationships between classes really define whether or not something is going to use inheritance or composition. Then we're going to go through some demos. I'm going to show you what basic inheritance looks like. We're going to take a look at how we can create inheritance in Java. And then we're going to do the same thing for composition. I'm going to show you how to use composition inside Java. Then we're going to look at an interesting topic that confuses a lot of people, which is polymorphism. We're going to ask the question of what really is polymorphism. Do a lot of people that we talk to even understand what it means, even though everyone kind of has an idea of what polymorphism is? A lot of people can give examples of polymorphism, but what is it really? What is the core of polymorphism? We're going to answer that question. Then we're going to get into a discussion about why we actually favor composition. And this is somewhat of a debated topic, but I'm going to give you my advice on this topic and tell you why in Java you should really be trying to use composition instead of inheritance wherever possible. And then finally, we're going to cover the topic of interfaces. One of the things that we're going to need to be able to do in order to use composition instead of inheritance is to make use of interfaces, and I'm going to show you why and how to do that. So let's talk a little bit about the ISA and HASA relationship in Java. And really, what the purpose of discussing this is because in Java, you're pretty soon going to find, as you're programming in Java, that classes don't stand alone, that classes actually need to depend on other classes, that you really have relationships between classes. So one class is going to be related to another class in some way, and they're usually going to be related through either an ISA relationship or a HASA relationship. Let me give you some examples here. You can see that there's some relationships that we just think about in real life, which are relationships like a cat, it's an animal. A car, well, it has wheels, it has an engine. A train also has wheels and an engine. A car and a truck, they're both vehicles. So you can see how these classes or these objects in real life are related to each other. And both of these relationships that I'm talking about here in all these cases are either an ISA relationship or a HASA relationship. We said that a cat is an animal. A car has a wheel or has wheels. A car has an engine. Really, when you think about how do I tell the difference between inheritance or composition, it's as simple as that. If you would say that something is another type or a subtype of a type, then it's an inheritance relationship. And if you would say something has another thing, then it's a composition relationship. And really all that means is that inheritance means that something is related to another thing in a tree fashion, that it inherits from it, that it is a subtype, it's a more specialized type. And for composition, it just means that it's composed, so it's made up of these other types. And really this all comes from an important need in Java, which is to be able to reuse code. The reason why we model things this way is it's partially to make things a little bit simpler and easier to understand and grasp, but really a lot of it comes down to the ability to reuse code, either to reuse some code that is common for two types, or to be able to reuse some code that operates on a type so that it'll operate on multiple types that are alike in some way. So let's take a look at what specifically is inheritance. If you look at this example I have here, you can see that I have an example of an animal and a cat. And a cat really is an animal. It is a type of animal. So this relationship is appropriate. And when you think about what's going to happen here, why are we modeling inheritance this way? One of the reasons is because an animal might have a lot of things that it does that all animals do. For example, animals eat, most animals I think sleep, and they reproduce. So all of these types of functionality you could basically build into an animal class. And then if you had a cat class, you wouldn't want to have to repeat all that. You would want to be able to utilize, you want to be able to say, a cat is an animal, but here's what it does differently. And so I'm going to specialize it. And this really comes into play if you had multiple types. You had a dog and a raccoon or whatever types of animals, you would want to be able to share this common code, this common functionality from animal amongst all of those derivatives of the animal type or the subtypes of animal. So that's really what inheritance is. It's really saying that something is another type. And one caution with inheritance is you have to make sure that your type really is going to be treated as that other type, which means that it needs to be able to be substituted anywhere that the higher level or the base type would be used. So for example, in this case, if you had some code that was using an animal, anything that inherits from animal should be able to be used by that code. Otherwise, your relationship is kind of broken, because if a cat can't be used anywhere that an animal was used, if a cat isn't truly an animal in all of the contexts that an animal is used, then it really is not properly modeled with an inheritance relationship. And one thing that you'll find as we discuss this a little later on is that there's very, very few things that are actually truly an is-a relationship. A lot of times you're going to find some way that that relationship breaks, and that can cause a lot of problems in your code if you're depending on it. So now let's look at composition. Composition really is a much simpler topic. It is something that I think we understand a little bit easier, which is basically that something is made up of some other parts. So in this example here, I've got a car, and inside my car, you can see I've got wheel, I've got engine. A car is made up of these things. So you have a car, and then a car contains some wheels, contains an engine. It's a really simple relationship, and anytime that you see this kind of relationship, you can model it as composition. And I'm going to show you in Java code how to model both inheritance and composition. But this is the basic idea of composition. It's also known as aggregation, which is that this car is made up of these other classes, and that's how these classes are related to each other. So let's look at an example of inheritance in Java. I've got our Hello World program open, and we've got our printer class up here. And let's go ahead and change this so that we're using some inheritance here. One thing about a printer is that it is basically a kind of machine. So we could envision that perhaps there's a base class that we could use that our printer would inherit from that's called machine. So what I'm going to do is I'm going to take this isOn, this functionality or this state of isOn, and I'm going to move it up to the machine class that we're going to create, and we're going to make the printer inherit from that. So it's going to derive its isOn functionality from the machine class. So I'll go ahead inside our program, and then I'll add, under printing, I'm going to add a new class, and we're going to call this machine. And then this machine class, let's go ahead and move this isOn up to there. So we're going to take everything that has to do with isOn. I'm going to create this variable in our machine class. And then we'll create a constructor for our machine class that handles the isOn. And we'll take this setting of the isOn here out of the printer. So in the machine class, we'll do public machine. And then we'll have it take a Boolean for isOn, then we'll set this dot isOn equals to isOn. So now we have a machine class that has an isOn, and that's all we're really going to put in the machine class is this functionality. We're going to also add some methods. Let's add a public method called turnOn, and this will just be very simple here. All it's going to do is turn on the machine. So we'll just say isOn equals true, and we'll make another method called turnOff, and it will just set isOn equal to false. So now we have our machine base class. We've got our printer here, and it's trying to use this isOn that doesn't exist. So we need to inherit from the machine class. So I'm going to make printer extend machine. So now printer is basically inheriting in Java. This is how we do inheritance in Java, is we just use this extends keyword, and you can only extend one thing because we cannot inherit from multiple classes. So printer is going to extend machine. It is a subtype of machine. We've got a little bit of a problem here that it says implicit superconstructor machine is undefined, must explicitly invoke another constructor. So we actually have to call the constructor of machine since we made the machine constructor take a variable. So one nice thing about using Eclipse is we can just click here in the margin, and a lot of times you can just have this automatically be fixed for you. In this case, we don't have that option, but what we can do is basically we're going to just call the constructor of machine and pass it in the isOn flag. So we're going to use super isOn, and what this will do is this will make sure that it calls the constructor of the machine class. Super just means call my parent or who I'm inheriting from, call that constructor, or use the attribute. It just refers, just like this refers to the current class that we're using. Super refers to the parent, and we'll pass the isOn there. Now the other thing that you'll notice here is that we can't use this isOn because it's not visible to us. And that is because if we look in machine, we made isOn be private. What we can do is we can change this to protected. And what that will do is it'll allow any subclass, any children of machine, anyone who inherits from machine, to be able to access this variable as well. So now you can see in our printer class we can access the isOn. So let's go ahead and run this code just to make sure that what was working before is still working. You can see we had created our printer with it being set to on and a serial number or model number of my printer, and then we did this print colors. So I'll run this, make sure that this works. It still works. Let's go ahead and change this so that we're going to call print, and we'll do one copy. And now we should see that it is set to on, and the printer is set to on. And now what we can do here is, because we've used inheritance, because we have inherited from machine, we can call this turn on or turn off method. So we should be able to do myprinter.turnOff, and because it inherited from machine, it has this method, and turn off should turn the printer off. So now if we print one copy after turning it off, we can see now that it was on and then it turned off. So just to recap, what we did here is we created this machine class, and then this machine class, we put this isOn. We moved it up from printer so that all machines could have this isOn, because all machines have this in common. And then we created a turn on and turn off method that flips it from true to false. Then in our printer, because we had created this machine constructor that took the isOn, we needed to actually call super from inside of our printer's constructor and pass on the isOn so that our machine class, our base class, could be properly constructed as well, because it requires this isOn to be passed into its constructor. Then everything worked fine as long as we were able to access this isOn from our subclasses, which we made our machine isOn protected so that printer could access it. And then printer just worked as normal, but now what we've done is we've extracted out this concept of being on to a higher level, to a machine, and our printer has inherited from machine by extending machine. So now let's look at a basic example of composition in Java. So I went ahead and I created a new class for us called a paper tray. And we're going to use this because a printer usually has a paper tray. That's usually a part of a printer. So while a printer is a machine, a printer has a paper tray. And so we want to include a paper tray as part of our printer. So I've created a paper tray class, and this paper tray class is pretty simple. It just holds a number of pages, and you can add paper to it, number of pages to it. It keeps track of how many pages it has. You can use a page, and you can check if it's empty. So we're going to kind of simulate a real printer with this. So what we're going to do here is we're just going to create a private variable of type paper tray, and we'll call this paper tray. And this will be our paper tray. And we need to make sure that we either initialize it here when the printer is created or inside the constructor. I'll go ahead and just initialize it here so that as soon as this variable is created that it's initialized. We'll create a new paper tray. And then, so now we have a paper tray. This is our composition. A printer now has a paper tray. Now let's go ahead and utilize this just to see how you would actually utilize composition in the real world here. So let's go ahead and make our print method depend on having some paper in the paper tray. So we'll change it so that when we do our print of printing copies, we'll go ahead and print the copies while our copies is greater than 0, like we had done before, and we'll put an AND condition here, and we'll say AND paper tray dot is empty, or and not paper tray is empty. So as long as the paper tray isn't empty, we'll continue to print our copies. And then let's go ahead and send a message if the paper tray is empty. Let's say if paper tray is empty, then we'll do system.out.println load more paper. So let's go ahead and see how this would work here. So I'll go ahead and just leave our example here. In fact, let's just change this to try and print one page. So let's go ahead and run this. So we're going to try and print one page, and you can see it prints load more paper because we haven't actually loaded any paper into our printer. It's trying to use this paper tray, but there's no paper in it. So let's call myPrinter.load paper. But you can see we don't have a method on printer to load the paper. A printer should be able to load paper, so let's go ahead and create a method. We'll pretend like we already have one. And let's load, let's say, 3 pages here. And one thing that you can do in Eclipse is you can go ahead and write the method that you want first. I like to program this way so that it is a little bit easier to use your classes by trying to use them first. And then you can just go over here and create a method automatically. Eclipse will do this for you. So now it automatically created this method for loading paper. And I'm going to just change this so that it's the count. And then what our load paper method is going to do is we're just going to call paper tray dot add paper, and we're just going to add whatever that count is. So we're going to use this class that we are using in composition, this paper tray that belongs to our printer. So let's go ahead and run this now and see what happens. Now you can see it did print my printer is on. And if we tried to print 3 pages, you can see it printed it 3 times. But if we try to print 4 pages, it's actually still letting us print 4 pages. So there's a problem here. We're not fully utilizing our paper tray. So let's go into printer and see what's going on here. Every time we're printing, we need to make the pages in our paper tray be 1 less. So we'll go into paper tray and we will say use page. So we're using a page in the paper tray. So we're treating this paper tray as an object. We're letting it handle its own data. We're just saying we're using a page, which is kind of the benefit of composition here, is that instead of trying to manage all this state and manage all this stuff inside of our printer class, we're using a paper tray, a concept of a paper tray, and so we're encapsulating that data and that logic in the paper tray class. So let's go ahead and run this now and see what happens. Now you can see it's behaving as we expect. The page printed 3 times and it said load more paper. So that's the basic idea of composition, is just that you have another class and your class has an instance of that class. In this case, our printer has a paper tray. And I wanted to show you more of a real world example. So I'm actually showing you how to use a class that you might have through composition. So let's talk a little bit about polymorphism. Polymorphism is a pretty difficult topic. A lot of people are very confused by it. They don't really understand what it means. So let's try to break this down and really understand what is polymorphism. Well, polymorphism, the word comes from the word many, poly meaning many, and morph meaning form. So what it really means is many forms. And it's still kind of a confusing concept to a lot of people. I think if you ask a developer, I know I've been on both sides of an interview asking the question and being asked the question, a lot of the response will come out something like, well, if you had a shape and then you had a square and then you had a draw method and so on down the lines, describing an example instead of really understanding what is polymorphism, what is the base concept of it. So I'm going to try and make this as simple as possible. There's 2 components to polymorphism. You have some code that's dependent on some kind of interface. And when I use the word interface here, I just mean some method of operating with it, some way that that code is being used or that class is being used. An interface for a class is simply just the methods that exist on that class. So you have some code that's dependent on some methods that exist in a class or some methods that are defined. And then the second component is that you have behavior of that code is determined by the actual class that's implementing that interface. So what that means is that when you actually use that code that's dependent on the interface, what the methods that it's going to call, they're not preset. We don't know what they are. That code doesn't know what they are or what they're going to do. Instead, what happens is when that code runs, depending on what type is actually implementing that method or that interface, that's what's going to happen. So a good way to think about this is if you ask someone to give you something to write with, an interface would be something that writes, and they hand you something. You don't know what it is. If you ask a question, give me something to write with, you might get a pen, you might get a pencil, you might get a marker. All of those things are able to write. Think about it as the write method. But depending on what you get is what gets put on the paper is what it's going to look like. So if you got a marker, it might be a thick markery line, it might be a red line if it's a red marker. If you got a blue ballpoint pen, it's going to be a small blue line. If you got a pencil, it's going to be a pencil line on that paper. So that's really what polymorphism is. It says, hey, I'm as the user of the code that's using some interface, I don't know what you're going to give me. What actually implements that interface, or what I actually get, is what's going to determine the behavior. So let's look at an example of this. In this case, I have our animal class here, and our animal class has a method called make noise. A lot of animals make noise, so we have a base method in our animal class called make noise. Now we're going to use inheritance here, and we have a dog and a cat, and they both inherit from animal. They're both types of animals. So what we're going to do here is for dog, we're going to redefine that make noise method, and we're going to put out bark. We're going to make the dog bark. And for cat, we're going to redefine the make noise method. We're going to override that, and we're going to have a meow. And so if we had some code that was using animal, we don't have to specify in that code. That code doesn't need to know whether it's working with a dog or a cat. Instead, it will program against the animal's interface, which is against an animal type with a make noise method. And at runtime, when we run our code, if we have actually assigned our animal to a dog instance, then it'll do a bark. If we've assigned it to a cat instance, it'll do a meow. So really, polymorphism is just that ability for, at runtime or dynamically, for that code to be able to call whatever method is implemented by the class that inherits from the base class, whatever the real class is, the underlying type. So that's a real simple way, and I'm going to show you how we can actually do this in code. So let's extend our printer example a little bit further here, and let's look at polymorphism. So what we're going to do here to set this up is we're going to go into our machine class, and we're going to basically make polymorphic behavior on this turn on method. And the way that we're going to be able to detect this is we're going to print out when the machine turns on a certain message, and we'll print out a different message when the printer turns on. So we'll do system.out.println, and we'll say machine is on. So now what we can do to demonstrate this is we'll go ahead and create our printer, but the way that we're going to create our printer here is we're going to use a reference to machine. So instead of creating our variable type as printer, we're going to use machine. Since a printer is a type of machine, we can just actually use the printer or the machine. This machine variable can hold either a printer or a machine. Anything that inherits from machine, anything that is a machine, can be held by this variable. So we're going to actually create a new printer here, though, even though this code is going to act on it as if it's a machine. And we'll call machine.turn on. So let's go ahead and run this. And you can see that machine is on is printed because printer doesn't have a turn on method. It's using the one that's inside machine. Now, let's see how we can actually make this polymorphic. If I go into our printer class and I override, which is to create a new implementation for the turn on method, then we should see that turn on method for the printer is going to be called instead of the one for machine when we're using a type of printer. And in Java, the way that we override a method is we use this attribute here, or this annotation in Java called override. And you don't actually have to use this, but this makes it so that the compiler will check to make sure that when you put it here, if you don't override a method that actually exists, if your override isn't going to work, it's going to give you a warning, it's going to give you an error. So I'm going to create a method called turn on, and it has to be the exact same method signature that exists in the parent. And in Java, all methods are virtual. What that means is that I don't have to tell the compiler that this method can be overridden, that we can have a method that is going to override this in our subclasses. Instead, by default, all methods are virtual. So this method is going to be called if the type is of printer. So let's go ahead and change this turn on. Let's make sure that we call our super turn on so that it still does actually turn on the printer. But let's change our message here, and let's add an additional message besides what was happening in the machine. Let's go ahead and do system.out.println, and we'll print warming up print engine. And let's go ahead and change the order here so that we're actually warming up the print engine before we actually turn on the machine. So now I'll go ahead and run this, and we still have a reference to a machine here, but because the type is printer, it's going to use the printer's turn on method. So you can see that it said warming up print engine and then machine is on. So it has actually called this method, and it determined which method to call based on what this type was. So we can prove that that's true by changing the type here. If instead of a printer, we change this to say new machine, and we say true, or we can say false here to start it in the off state, and we run this, you can see that it's now it's now just saying machine is on. So it's actually calling the method inside machine. And that's really what polymorphism is it's this ability that based on what type this variable is assigned to, even though this variable itself is actually a machine type, is holding reference to machine type, if this is a printer, if we made this a printer, then this same call here to turn on will call the appropriate method. So I wanted to touch on this topic real quick before we move on here, since we're talking about inheritance and composition. I think it's really important, especially in Java, to mention that you should be favoring composition. Basically, almost all inheritance can be rewritten as composition. We can find a way to make something that is inheritance composition. And I'm going to show you some ways to do this. It might not seem like this is true, but let's go through this and maybe you'll see what I'm talking about here. So one of the problems with object-oriented programming, it's kind of changed. The idea behind it has changed. Back when it was first used, a lot of inheritance was used. Now it's more composition, because object-oriented programming was originally about modeling the real world, and we found that that doesn't quite work out all the time. It's still good, it still helps us, but really what object-oriented programming today is about modeling interactions in a system and roles and responsibilities. And however you can do that, what makes sense inside of that system, that domain that you're creating, it really is how you should model your classes, not exactly after physical objects and what exists in the real world. And with that knowledge, you can divorce yourself from the idea that the is-a relationship has to be implemented in terms of inheritance. And this is kind of opposite of what I had talked about before when I said, well, is-a is inheritance. There's a way to rewrite is-a so that we can actually make it a composition. We can make it a has-a. And one way to think about that is we can take an is-a relationship and we can say that same relationship has a implementation of something. So for example, if we took our example of an animal and a cat, well, a cat is an animal. We could rewrite that and say a cat has an implementation of animal. So we're going to put an animal implementation inside of cat so that cat can use all of the methods and all of the functionality that's inside animal, but it doesn't have to be one. And this distinction is really important for one main reason, which is inheritance is really difficult to maintain. A lot of the messy code that we've inherited over the years is because of inheritance itself being used in that code base. I know that I've personally worked in a lot of code where inheritance was overused, and it makes things really difficult because when you make changes to a base class, especially if you have a large inheritance tree, those changes ripple down and they cause breakage in all these subclasses. The same doesn't happen so much with composition. With composition, you kind of know what you're in for. So that's just some basic advice to try and favor composition. And I'm going to show you some ways that we can do that using what we're going to discuss next, which is an interface. So let's talk about interfaces. This is another programming topic that confuses a lot of people, and it's really not as difficult as it seems. Basically, in terms of Java, in terms of what we've discussed so far, an interface is just inheritance without all the baggage. It doesn't have all this weight that's associated with inheritance, all the bad things that we had. And some of the weight that's lost is the implementation details. When you create an interface is just going to specify what the contract is or what the method's signatures look like for some class that's going to implement that interface. When we use inheritance, we might have had our animal class, and our animal class might have had some methods that had some default behavior, maybe a walk or a eat or sleep. Using an interface, we might still have all those same methods. We're just not providing any default implementation. We're saying if you implement this interface, if you're going to inherit from this interface, basically, that you have to provide these implementations yourself. And so that's the basic difference here. Now, the thing that we get when we do this is suddenly we can have multiple implementations. We can implement multiple interfaces. One class, an animal or a cat, could be an animal interface. It could also be a mammal interface. It could also be a furry interface. Whatever interface that you want, it can have multiple ones of them, which you can't do in Java with inheritance because you can only inherit from one object or one class. So we get that ability, and the other ability we get is that interfaces work with polymorphism. So this gives us a way to really break apart our inheritance relationship and change it to a composition relationship where we're going to use an interface as a substitute for a base class. So an interface is just the definition of what methods need to be implemented by some class. That's the simplest way, I think, to put it in Java. And here's an example. This is our animal example again. And I name interfaces I and then the name, so I animal. This is really not a Java convention. When I program in Java, I do this anyway because I like to know what is an interface, and to me this is the most clear way. This is perhaps more of a C# convention, but you can do whatever you want. The standard way in Java to this would be to have animal and then animal impl. I find that a little bit confusing, especially the way that we use interfaces today. But with that said, this example, what we're looking at here is we have an iAnimal interface. So this is our interface. It's going to define some methods, maybe eat, sleep, walk, and then you can see, looking at the right first, we have our dog and our cat, and they both are going to implement this iAnimal interface. It's just like inheritance, except that they're not getting the methods, they're just getting the requirement to implement those methods. So if we had an eat method, for example, dog would have to implement it, cat would have to implement it. Looking at the left here, this is where we're going to get into that kind of trick where you can actually change inheritance into composition. We could have a default animal, which doesn't really model the real world. There's not like a default animal, but we could use that to put all of our methods, all our default behavior inside there. Then we could actually have dog and cat be composed of default animals. Each one of them could contain a default animal, still implementing this animal interface. And then when they want to, for example, eat, they can just call default animal.eat and return the result of that. And if they want to do something special, they could just not call the default animal eat, and they could provide their own implementation. This gives you kind of the best of both worlds. You can both reuse the code inside this default animal class, but instead of using inheritance, you're using composition here. So let's convert our example here over to use an interface instead of inheritance. And we'll make it so that we can actually do polymorphism with interfaces instead of inheritance. And then we'll actually be able to use composition and interfaces together to avoid inheritance altogether and basically duplicate the same functionality of inheritance without all the drawbacks. So let's take this one step at a time, and the first thing that we're going to do is we're going to change our printer so that it is no longer inheriting from machine. Instead, let's create an interface called iMachine. And what we'll do here is we'll take out this extends machine and we'll put implements iMachine. And this implements keyword is how you implement an interface. Just like extend works to inherit from a class, implements is used with an interface. So I'll go ahead and let Eclipse create this interface for me. This is one of the nice things that you can do in Eclipse. It's automatically going to be able to create this because it realized that I was trying to refer to something that didn't exist. So I'm going to click Finish here. And so it's created my iMachine interface. And on my iMachine interface, let's go ahead and declare some methods that are going to exist. Now remember, you're not going to be able to declare data. You're not going to be able to declare the actual implementation of a method, but just what this interface looks like. So let's create our methods. Let's create our turn on and turn off method, because any machine should have turn on and turn off. Now, we had implemented this in machine, but for now we're just going to ignore machine and we're not going to utilize machine at all. We're going to just make it so our printer is implementing this interface instead. And so now you can see we've got a whole host of problems here because we don't have the ability to call this isOn, or to use this on isOn, or to basically use this base class since we're not using the base class anymore. In fact, what we need to do is we need to implement these methods ourselves because we're not getting the implementation from anywhere. When we inherited from machine, machine was providing us with these turn on and turn off methods. So I'll use Eclipse here again, and you can see I can just click this to add unimplemented methods. And when I do that, what it's done here is it's created a turn off method and a turn on method. In fact, we already had a turn on method, so it didn't try and recreate that because that's part of the interface. But it created a turn off method because we need to have a turn off method. So I'm actually going to move this isOn back into our class for now so that we can implement this interface properly. So I'm going to create a private variable, a Boolean called isOn, and I'm going to set it in our constructor here, just like we had done before. We're going to say that this isOn equals isOn. And now when we want to call turn on, we're going to just implement this ourselves. We're going to say isOn equals true. And then for turn off, we're just going to set isOn equals to false. So now you can see we have no dependency on machine. On the machine class, we created this iMachine interface, and we're implementing this interface by having an overridden method for turn on and one for turn off. Now what this is going to allow us to do is to basically, instead of referring to our object as a machine, we can basically use this iMachine interface here, and we can set our printer equal to this iMachine interface. And we have to import this type, of course, to be able to use iMachine. So now we have an interface that is referring to our printer, and then we can call turn on that interface. So we can call any methods that exist on this interface. We don't have to know what the implementation is. That printer implements it. And so let's go ahead and run this and see what happens here. So you can see it just has the warming up print engine because it's calling the turn on method in printer when we use that interface. Now let's take this one more step further and let's go ahead and make it so that we are going to use composition in order to avoid having to repeat this logic, because we had this logic for the isOn in machine, and the problem with using an interface, a lot of people complain, is, well, I don't want to repeat this code and manage this isOn, this logic in every single class. If we created another printer or another type of machine, we'd have to implement the machine interface and re-implement turn on and turn off. So we're going to use machine as kind of a base, but we're not going to inherit from it. And the way we're going to do that is we're going to have machine implement the iMachine interface. And then we're going to have our printer class have an instance of a machine. So just like we did with Papertray, we're going to create a machine variable called machine. And we're just going to leave this machine here. And then in our constructor, we're going to construct our machine. So I'm actually going to take this isOn variable out again. And instead, what we're going to do here is we're going to say that machine equals new machine. And we're going to pass the isOn here. So the machine is going to manage this. It's going to have that logic. We're going to take this logic for handling the isOn out of our actual class. And then this turn on method, we still have to implement a turn on and a turn off method. But all we have to do here is we can just say machine.turnOn. So we're going to delegate. This is called delegation because we're going to implement this interface by delegating it to our internal machine class. So for turn on, we just call machine.turnOn. For turn off, we'll just call machine.turnOff. And then this has actually helped us to figure out part of the interface that was missing that we didn't even think about here is that this is on. We need this iMachine interface to provide a way for us to tell if the machine's on, not just to set the state of being on or off. So I'm going to go ahead and implement a method here that would allow us to check is on. So I'm going to change this instead of a variable to a method call. And then we're going to create this method. But we need to create this in our interface first, and then we want to create it in the machine because we don't want to implement this in our actual printer. So let's go into our interface here, and let's create a method that returns a boolean called isOn. And now you can see both machine and printer have an error here because they need to implement this method. So I'm going to click Add Unimplemented Methods, and for machine, it's going to have an isOn, and the way that we implement isOn is to return the value of our isOn variable. Then in printer, the way that we're going to implement isOn is we're just going to return the value of our machine's isOn. We're just going to delegate our call. So we're going to return machine.isOn. So now you can see that the same thing here when we want to check our isOn, we're just going to do machine.isOn. So now you can see we're actually not inheriting from machine, but we're able to use machine through composition. So we have the same polymorphic behavior. If we go to our main class here and run this, we're now using iMachine, and our iMachine can either hold a printer or a machine, and it's going to call the turn-on method. And so if I call this turn-on method here, you can see it's calling the code inside machine. And if we decided that we didn't want our printer to use machine's method, or we wanted to use machine's method but we wanted to do something else as well, we can just do system.out.println, for example, and we can say warming up printer. Now if we run this, you can see that it's calling our code, which is delegating to machine. So let's go over what we covered in this module. Well, the first thing that we did is we talked about the ISA and HASA relationship and how inheritance and composition are different and how they're modeled differently by the ISA relationship and the HASA relationship. Then I showed you an example of using basic inheritance in Java. We saw how we could actually create inheritance inside Java and inherit a class or inherit some data from a class. Then we went through and did the same thing for composition. I showed you how in Java you could use composition or create a class that's composed of other classes. Then we covered the difficult topic of polymorphism, and we really strove to understand exactly what polymorphism is in Java. Then we went through and we talked about how you should favor composition, and I give you my personal opinion and some advice on why composition is better to use than inheritance, especially in Java where you can't do multiple inheritance. And finally, we talked about an important concept, interfaces, which allows us to use composition and still allows us to do polymorphism. Well, that's it for inheritance and composition. I hope you learned a lot about using inheritance and composition in Java. And in our next module, we're going to get into a very interesting topic, which is generics.